Hello everyone, this is Charlie again, and let's go ahead and get started with the plumbing section. And let's go ahead and get that switched out there, that's good. Position myself a little bit better. Alrighty. Yeah. So I'm hoping nobody ends up getting an inspection that's kind of this bad. Um, Obviously I'm putting this up here as a joke a little bit, but actually this was a house and we did do an inspection and this is what we found. So when we were teaching in the Joliet area, we would use foreclosed homes quite a bit. And we still do use foreclosed homes. You find a whole bunch of stuff wrong with them. But on this one, either the toilet was cracked or for some reason they couldn't winterize it enough to keep the antifreeze in the toilet, so it kept leaking out. So somebody thought it was a good idea to take a rag and stuff it in the toilet and hold it nice and tight with a 2x4 in there. I'm sorry, I can't keep a straight face when I talk about it. I just think it's so ingenious. It's fantastic. All right. But in all reality, let's go ahead and get started. Excuse me. And we're going to deal... Oops, I think we jumped the gun here once. Okay. So there are some home inspectors that go ahead and purchase pressure gauges. You are going to have to memorize some of the pressure numbers that we run into and when it deals with water pressures. But for the most part, and I know we don't do it, there was a short period of time where I did, but we don't put any sort of pressure gauges on any of the water systems at all. I used to have this Toro, it was a Toro static and a Toro residual gauge together. And it was mostly designed for determining if you had enough water flow to install a water sprinkler system outside for your yard. But it did help determine what the static pressure was and also the residual pressures. But we don't really do so much of that here. We're more concerned of the term functional flow. Now that functional flow in the home inspector business does have a definition. You are expected to know the definition of functional flow. All right. So when you're in the same room, such as a bathroom, you should be able to have two fixtures running at the same time, and there really shouldn't be any sort of noticeable loss when one is turned on and the other is turned off. I think we've all heard that joke where somebody's in the shower and then someone else flushes the toilet and they end up getting burned, on there, and we all giggle over it, and it does seem kind of funny in its own way, but we really don't want that to happen. So I have had a situation, and I want to say this was over 20 years ago. So when I did this test originally, I would turn on the water to the shower or the bathtub, usually just shower, and I turn on the hot and the cold water when I'm doing that. And then I would flush the toilet and see if the water flow changed. And then I would turn on the hot and cold water to the sink and see if the water pressure changed. And nothing changed during some of the inspections that I did. And then one of them I got a phone call, which was a little eye-opening for me. And it happens, my house still does it. I love it. And it does happen, it is true, but sometimes we have to look at it and see how bad is it. So I did have one house where the people ended up hiring me. I did what I normally do. They move in, and their hot water pipes were corroded, and they didn't have any flow coming out of their hot water pipes. And because I turned the hot and the cold water on at the same time, and I didn't check for temperatures or anything else like that, I didn't know better, back then. We tend to learn the hard way, which is some of the stuff that I try to share with you. These are mistakes that I've made or friends of mine have made, and I kind of don't want you to make the same mistakes. So, the hot water had galvanized pipes on it, and they were corroded up where the hot water wasn't flowing. But I didn't recognize that because I had the hot and the cold water running at the same time. So now our process is we run the hot water only in the shower, and then we run the hot water in the sink and see if it makes a difference between the two of them. And then we do the same thing with the cold water and flush the toilet with the cold water. Whenever it is a low water flow, one or the other, make sure my clients are aware of it. And at that point in time, we see if we can even get a hot shower out of it. Repiping houses isn't really a cheap thing to do. And it's not saying that we have to be responsible for it. But at this point in time, I really feel that I should have done it a different way. So functional flow, 2 fixtures in the same room in use at the same time without any sort of significant drop from either one of these things. Service pipe. In our SOP, we have to describe the material of the service pipe. That's different than the supply lines. So the service pipe is what comes in from the street, and that's usually where it stops at the water meter. After the water meter, those are going to be our supply lines inside the house. So it's basically copper, galvanized, plastic. Lead is a very common one in our area. Copper, I think, is pretty easy to identify just because it's copper colored. Plastic is also pretty easy to identify because it's plastic. Typically, those will be on a well system, at least in our area here, they will be. We do have some galvanized pipe for supply lines coming in there, but that's very rare in our area here. Now, the biggest clue, if it's galvanized, and it would look kind of like lead as well, galvanized is not soft temper. And anytime I use the word soft temper, I'm talking about something being flexible. If it's hard and stiff and not really bendable or flexible, that's hard temper. So copper comes in both hard temper and soft temper. Some things, if we bend them, they'll kink. Other ones, like gas lines, come in a coil, and we can straighten those out. Lead, I'm not aware of any lead that was ever hard temper. Lead is a softer material, and most of the water lines coming into that are bendable, that are silverish in color, are going to be lead. The telltale sign for a lead pipe is going to be that egg shape at the end. But even with that, in Chicago, they're making a big push to put water meters in all the houses. So they're actually cutting that egg off, and there is no more bulge or egg-shaped thing at the end. It's just straight on, and then the valve, and then the water meter that's there. So if the pipe itself is curved, it's probably going to be a lead pipe. If it's hard and straight, it's going to be a galvanized pipe. Just a little chart about when things were used. So it was kind of all the way up to the 30s, and I think it was more into the 50s and 60s in the Chicago area that we kept using lead pipes. Now, one thing about lead, if you're not familiar with it, and it does really affect younger people, pregnant women, things like that, they're very concerned about it. So doing a little bit of research in your area, finding out what the lead ratings are. In Detroit, it's going to be one thing than it is in Chicago. I forgot the name of the chemical that they were putting in the water, but it creates a coating on the inside of the lead. And that coating has really done a wonderful job at keeping our lead levels low in our drinking water here in Chicago. However, as I mentioned, they were cutting the pipes to put the new water meters on. And when they did that, they basically disturbed that coating. And those homes that they started putting those water meters on were getting really high spike levels of lead in the water. So much so that they actually stopped that program where they're putting water meters in the houses, especially those with lead pipes in them. All right, so they're not doing that anymore. The cures for lead water services, if you go ahead and put in a new water line coming in there, you might be looking at 15, 20,000, and it might even be more depending on the run to get to the street and the tap in. They're going to have to bore underneath the house. Typically, the new line's going to have to be 10 feet away from the waistline, so it's not going to be in the same trench anymore. It's kind of a big deal. I and since most of the homes in this area do have, or I should say older homes do have lead service lines, I kind of explain to my client, just treat them as if it is. I don't even encourage testing for lead in the water anymore, because if I don't get that water sample that's right there, that was in the pipe for like 24 hours or so, then I'm not going to get a good sample. It might come back negative. And I don't want to give my client hope saying, oh, I don't have a lead problem here because it came back negative. Well, that may not be true. The water might have only been sitting there for a minute or two, or just passed through it, in which case we're not going to get any sort of lead readings from it, just because the water hasn't been there. It's got to leach into the water overnight. So I'd rather people treat it as if it is a problem. And you could purchase filters with, that are about $150 a year to change them. And so it's doable. There's management stuff. And if they want the permanent fix, then they're going to have to start looking for a house that doesn't have a lead service line. Most of the stuff that we have here in the Chicago area are going to be copper service feeds. Well systems will either be a cross-stitch polyethylene or a PVC. We don't really do too much with polybutylene anymore, but nonetheless, we're going to classify all three of those as a plastic anyway. Mostly they're going to be in well systems where we'll have copper coming in for the street supply water systems. So again, going back to the water flow, that's going to be our biggest issue. The bigger the pipe, the more water that's going to flow and the less friction loss. The interior smoothness of the pipe is going to create a lot of friction loss. Multiple bends in the pipe are going to create, friction loss and lower the flow. And depending on how much pressure is coming through the pipe is going to be what's going to create a high flow or a low flow. And of course, height. Water does have an elevation or does have weight to it. So the higher we push it up, the lower the pressure that's going to be. When you start getting buildings like the Sears Tower or the Willis Tower or the John Hancock building, the taller buildings, they're going to actually have to have reservoirs in areas where they catch the water and then they pump it up the next 20 stories or 50 stories, whatever it is. You can't have a pump that's going to lift it all the way up that high and still maintain a good flow and a good steady amount of pressure. So they actually have holding areas and they fill them up. But in residential buildings, typically we're going to be 3 stories tall at the most. Rarely are we going to be a 4th story tall. And usually you lose on average 5 psi per floor. So the exact number is 2.2 for every, you lose 1 pound for every 2.2 feet of elevation. So every 10 feet is what we're rounding up to be 1 floor elevation. So we just round it up to be 5 or round it down to be 5 psi for every floor. We'll go into the other numbers, what's normal in a second here. We're talking about the height now. So if we start off with a 60 psi service coming in from the basement, we go up 1 floor, we can expect 5 pound loss is what they're saying here. And that's just an average. And again, we don't really measure the pressure itself. I just want you to know what that is. All right. The diameter, and this one is a little bit of a math problem. This I actually found really interesting, and I had to throw out the old BS flag when it was first explained to me. I'm like, there's no way, But you take a 1/2 inch pipe, and they're comparing it to a 3/4 inch pipe. And this slide is showing that 3/4 inch pipe is actually twice as big as the 1/2 inch pipe, even though it's only 1/4 of an inch bigger. And by doing the math, that's the pi to 3.14. If we multiply that times the radius, and that's where the math on the bottom is, you can see the 1/2 inch pipe comes out to 0.195 square inches, and doubling that would be, well, let's round up to 0.2. We double it would be 0.4. And then you can see on the 3/4 inch pipe at the bottom, it's actually bigger than 0.4. So it's more than twice as big. So bigger pipes, easier flow of water, less friction loss, and greater amount of flow. And this is where they're talking about depending on the pressure and the gallons per minute. And friction loss is directly related to the gallons per minute. So the more water flow, through the smaller house, the more restrictions we're going to have. And that's kind of what this chart is explaining. I'd like you to know the term static pressure. That's the pressure of water when it's at rest. It's the potential of energy. So as the water's sitting in the system, if we put a gauge on it, it's typically going to be in our area, in the suburbs, I should say, about 50 psi to 60 psi, somewhere in that ballpark. Sometimes it'll be down to 40 and so forth. The way we work our water systems in the suburbs is most of them are with water towers. So we'll have a pump that'll pump the water up into a water tower. And if you remember what I said about the elevation and the amount of pressure that's built up on those things, usually those things are about 100 feet in the air or more. So because of which, if we get 5 pounds per every 100 or 5 pounds per every 10 feet, that's going to give me 50 pounds of pressure as that water is going to be pushing back into my water system. Not only that, but it acts as kind of like a bumper on a car, and it keeps any water from shocking as the pumps are running. So we just keep pumping water into the tower. They could turn more pumps on as needed and turn pumps off as needed, depending on the height of the water inside of the water tower. So they try to maintain a steady static pressure. The reason why they want that to be steady, no matter how much water is being used, obviously we use more in the morning as a community than we use during like middle of the day, or if there's lawn sprinkling going on versus nighttime. You know, the reason why they want a steady pressure is when you change the pressures of the water pipes in the ground, that actually shocks those pipes. And if they change significantly, they break the pipes, and they break them often. Now, going back to my fireman years, there was something that the water department would complain about the fire department all the time. Once a year, we call it hush and flush. We would have to go out to all of our hydrants and open up the caps and flush all the water out of them and spray all the valves and the threads and the caps and everything with a little bit of lubricant and put all those things back together. But opening up those hydrants allowed a significant amount of water to flow, and then shutting them down created a pretty strong water hammer on things as well. So that would actually shock our pipes. And honestly, I felt bad because it was like almost every time, especially in certain neighborhoods where the pipes are really old, we would bust those water pipes all the time. And in doing that, you're talking about get the big machines out, dig down where the pipe is broken. First, we got to shut the water off to the neighborhood. Then they're going to put a sleeve on that to fix the leak. In some of these areas, they got sleeves on top of sleeves. They're really bad. But anyway, getting back to what the slide is, static pressure is the pressure of the water at rest, ready to be used. All right. Residual pressure is the amount of pressure that's left in the water system after the water is flowing. All right. So what we're showing on this slide here is on the left-hand side, we have 60 psi coming into the water system. And where it's discharging with the water flowing, we're left with 24 psi. What they're trying to say in this slide is it doesn't matter the order of flow. If I go big pipe, little pipe, big pipe, none of that matters. It all totals out and equals out wherever it is at the final run, and that's going to be our friction loss. I want you to remember the term residual pressure and static pressure. Static pressure is at rest. So with these pipes, if the water was not flowing, it would be 60 on the left and 60 on the right. But with the water flowing, and we have, 36 psi friction loss, we're going to end up with 60 going in and 24 coming out. So residual, the amount of pressure that's left with the water flowing. Static, the amount of pressure that's present without the water flowing. Elbows, friction loss, obviously the more bends and stuff that we put into the pipe, the more friction loss that it's going to be. I think this is more of a common sense. There is no science to it. I don't know anybody who does the old loop-de-doop with the plumbing. I know I would, but, I'm kind of weird when it comes to that stuff. Galvanized pipes, they pretty much have a lifespan of about 60 years. And it's been roughly about 70 years since we started putting these things in. Now, there's a lot of people that will still replace with galvanized pipe. All right, so it still gets removed and put back in, and it's there. And I had I found a lot of home inspectors also are landlords, and they keep up with sort of fire laws with the size of pipe. That may be. Those numbers are not exact on there. And just for anybody else, let me pop up what Mark put on here. He was saying that he thinks that there's an error with the friction loss with the size of the pipe. And that may be true. I'm never afraid to make shit up. Pardon my language. But yeah, I'm never afraid to make up a number just to prove a point. All right. So I'm not worried about being accurate on the length and the friction loss and what's going to happen with it. The point I was trying to make is whether you go from a small pipe to a big pipe, the amount of friction loss is still going to be the same at the end results. It doesn't matter the order of the flow, is the point I was trying to make. Going back to the galvanized pipe, though. So, Les, and I'm drawing a blank on his last name, but it doesn't matter. I remember he has a lot of older buildings that have a lot of galvanized pipe in it. And he would actually insert air into these pipes. And he would have a pressure tank, hook it up to one of the spigots on there. And he would leave the water running. And then he would just turn the pressure tank on and off real fast. And basically creating a bunch of water hammers inside the pipe, trying to knock a whole bunch of this stuff loose, right? And from what he tells me, it works. The pressure would go down, and then he would go ahead and bang these things up a lot, and then it would free up, and everybody would be happy for a while. But as far as I'm concerned, my clients aren't going to be doing stuff like that, and I can't encourage them to do it. So we're going to run the water. We're going to look at that functional flow. We're going to give them the lifespan of the galvanized pipe, and if it's present, we're going to prepare them that some of these pipes might need to be replaced. I have found from experience that the hot water pipes do corrode up faster than the cold water pipes, which explains why the hot water lines will shut down first before the cold water lines do. I've also seen where people have taken where the pipes go horizontal and then they turn upwards, that little elbow right in there. I've seen where they've taken that off, cut it here, and that was just caked up, filled with a lot of debris because it kept falling right there. And they replaced that section, and that would give them another 10 to 20 years out of their plumbing pipes. Galvanized pipes, though, what I want you to take out of this slide is that they corrode from the inside, and it's kind of like having a heart attack. Everything just closes up on the inside until the water can't flow anymore. This is more or less of a kind of a joke as it comes in there, but this we actually did fine. So it was a galvanized plumbing system coming in there, and somebody decided to use electrical tape instead of Teflon tape or dope, and surprisingly it didn't leak. So maybe that is something that can work. Who knows? All right. So these are going to be test questions. You do need to know these items here. So any water pressure on a supply system between 20 and 80 is considered acceptable. In our area, 40 to 70 is what's kind of normal. Anything under 20, you're going to need a pump. Anything over 80, you're going to need some sort of pressure reducing device. Now that 80 psi, the pipes are designed for, I don't know the exact number, I want to say like almost up to 300 psi. They're pretty strong. But the 80 psi is when we start getting into the valves for dishwashers, washing machines, things that are automated that turn on and off. That's where it comes into play on that. All right. So this one here is what we're showing is over 80 psi. The device, as we come in, this water's coming in from the right, and it goes up to our shutoff valve. Then it goes into our pressure reducing device, and then we're going to have a pressure relief valve right after that. Sometimes the pressure reducing device and the pressure relief valve are actually built into the same thing. And then our water meter, and of course we're jumping over our water meter, pressure reducing device, pressure relief valve, just in case those have to be reduced. We're going to maintain ground and the same potential on both sides of those items where it's getting done. And the main purpose that we're bringing it down is, again, for those valves so that we don't damage them. Lower PSI, we're going to put a pump on it. So we're going to talk about well pumps as well in a little bit. We actually run them. We watch the gauge. We see how long it takes the gauge to drain down as the water is flowing and how long it takes the pump or the tank to fill back up. When these tanks get waterlogged and we don't have that much air pressure in them, then it ends up going on and off really quick, and there's not much we could do with that. We're going to either have to put a new tank in or add air to the tank if it doesn't have a bladder in it. So here's our initial setup. Water comes in from our well pumps it into our bladder tank, and everything works from there. So now the water's in the tank, we use it, we activate our pump, and you can see we're at 40 psi. The pump turns on, fills up our tank, builds up that pressure, gets to 50 psi, everything turns off, water flows, pressure drops, pump turns on, and that cycle just keeps going. Well systems. This is a test question that I am aware of. There is a line in the sand. They do want you to know the difference between a deep well and a shallow well. All right, and that line in the sand is 25 feet. Shallow wells are typically going to be, if you ever been to the forest preserve and they have those wells that you're going to pump up, those are shallow wells. You're typically going to have a surface pump that's going to create a draft and siphon that water out of the well in order to make it work. Very rarely are they going to be lined in any which way. They may have a stone liner, but they're going to be gapped and open, and the water table is just going to be that high that we're going to get water out of it. Deep wells are going to either be drilled, most likely. They may be bored, but usually they're going to end up being drilled. Again, anything over 25 feet is considered a deep well. Around here, they tend to go around 50 feet, and I've heard them as deep as 500. Once the well is done and the pipes are there, they're going to actually insert the pump into the well, and they're going to drop it all the way down so it actually sits in the water. And we're going to talk about a centrifugal pump versus a piston pump. Shallow wells, when we're pulling water out of it, that has to be more of a piston or a primer type pump. Where deep wells, we can use a centrifugal pump, so it actually pushes the water. It doesn't actually draw the water out. And I'm going to wait till I get those drawings up to try and explain that one. So dug wells, usually less than 25 feet. Bored wells, less than 100. Drill wells, here they're saying they go all the way up to 900 feet. I'm not aware of anything that deep, but I'm not saying it won't happen either. All right. We don't do too many drawdown tests in the state of Illinois, at least on the sales contracts up here. Anybody who does a well and septic certification or a well and septic inspection, that's usually mandated to be done by the seller of a home. And they have to provide that certificate from the well and septic guy to say everything's okay. So what they're going to do is measure the water level when it's at rest. Then they're going to be, I forgot exactly how much it is. I want to say it's like 5 gallons of water. And they want to see how long it takes to fill up a 5-gallon bucket. They're also going to measure to see how far down the water level dropped during that time frame. And then they're going to also measure the time frame it takes for that water level to come back up. Again, that's a drawdown test. I've never done one of these. I have had people ask me to inspect a well and the system or in the septic system. And all I could do is tell them is that, yeah, someone else is going to come and do it as well. We're going to operate this system, but that's really about it. I'm not going to be able to tell if they'll ever run out of water or the well will go dry. All right. Clearances. These numbers that are up here now are strictly for the test, per se. The Yeah, they're going to be strictly for the test. In the real world, um, we're going to be looking at pretty much 75 feet or more when it comes to stuff. At least it is in our area. So if the well has a steel liner on it or some sort of casing on it so that it's not open, I was talking about the dug wells before where they had stones stacked around them. If it's that type of well, then that has to be 100 feet away from the septic system. Obviously, it's easy for the wastewater to flow over and get in there. But if there is a liner on it or a casing on it, then it says you could be within 50 feet. Typically what we find on our separations is they're going to put the well in the front of the house and they'll put the septic field in the back of the house. But depending on the layout of the house and the land, it might be reversed or it might be on the left and the right. They tend to leave a pretty decent separation. The magic number around here seems to be 75 feet, even though everything is typically having a casing on it, so they are typically lined. But everybody just wants to keep a general number when it comes to it. So, all right, pump components. I think we kind of chatted on this already. We're going to have our pump, our pressure gauge, our tank as well, the on-off switch that comes there, an isolation valve, and usually some sort of pressure relief valve. And not too often do we do that. Pretty much the only pressure relief valve we're going to find is going to be on the water heater itself. The only time we see pressure relief valves is when there's either a backflow prevention device or some sort of pressure reducing device. And then we'll see it built into that. Short cycling, I kind of mentioned this earlier. The only water is not compressible. We can increase the pressure on it, but we can't compress it. So we can only compress air. And so as we fill it up with water, we have to have some air inside the tank as well, so that we can keep and maintain that pressure. If I didn't have any air and the pump was running, the pump was shut off after about 2 seconds because it would increase the pressure instantly. And then when the water was turned on, it would drop instantly. And now the pump is the only thing that's kicking on. And we're going to feel that when the water, it'll get strong, weak, strong, weak. It'll be kind of weird when it runs. So we want to have air inside the tank. That's going to be our bumper, and that's going to keep everything nice and even. I talked a little bit about the different types of pumps. Positive displacement, I think I used the term piston pump, and that's what we're looking at here. These are only going to be on shallow wells. I want to say that I'm going back to my drive the fire engine days. Mathematically, I think, when we draft from rivers or draft from ponds and such, we can lift water mathematically 34 feet. And that's with the fire engines and the piston pumps being able to pull these things up. I have never known anybody who was able to lift water that much. We're not really supposed to be even trying to lift water more than 20 feet. So if we're 20 feet higher than the riverbed or anything with it, then that's going to create a problem. But the good news is with positive displacement pumps, you are actually able to siphon. You're pulling water out of there, and then you're able to push it out. It's a specific amount of water for each stroke of that piston. It's going to be a specific amount of water that's going to be moving. All right. Going to the left side, the centrifugal pumps, the water comes in through the eye. So as we're looking on the left side of the drawing, the pipe that goes up and down and goes right into the middle, that's what brings the water in. All right. And as that water comes in, and that has to be filled up completely with water. This is not an airtight chamber. It cannot pump air through a centrifugal pump. A positive displacement pump can pump air, but a centrifugal pump cannot. So that has to be filled up with water, or water has to be pushed into it some way or another. It has to have a little bit of pressure to go ahead and get the water in it. Then the impellers start spinning, and when they spin around, they push the water to the outside edges, and then the opening at the top is where the pressurized water is going to come out of. Now, these centrifugal pumps can build on each other. So if I have a 500-foot well, I might have 4 pumps in there. All right, one is going to be all the way at the bottom, and then maybe every 100 or 200 feet, depending on the size of the pump, they're all going to kick on, and they're all going to take their turns moving the water up the line so we can get it to where we use it. I do want you to know the difference between a centrifugal pump and a positive displacement pump. A positive displacement pump can pump air, a centrifugal pump cannot. A positive displacement pump has a defined amount of water that moves for every stroke that it makes. A centrifugal pump creates pressure. So if I put these in multiple alignments, or basically in series, I can increase the pressure and increase the flow when it comes to it by putting them in line with each other. I couldn't do that with a positive displacement pump or a piston pump. Water shutoff, going through the main components. This is typically what we're going to see when we come into a house. We want to identify the water as where it comes into the street. That's our supply line. The state of Illinois SOP says that we have to identify where the water shutoff is. Most people will take a picture of it, say it's in the basement, north wall, whatever. I don't think they need you to put a measurement down and say exactly where it is. Just give a rough idea is fine. Where are we at here? Number 1, we're working our way from the house out. So let's start with number 5. That's a copper service feed. Number 6 is, it says here that's the backup shutoff valve. And I don't think it is. I think that was the primary one that was installed there. Now these gate or globe valves that you see there, anything that you have to twist like that, I would never touch that thing. In fact, I try to avoid turning any valve. Typically they're one-timers. I would explain this to my client as well. If there's an emergency and you have to turn the water off, this is one of the locations where you could do that. Number 7 is also a shutoff valve, but that's a ball valve, and we'll talk about that in a minute. These gate and globes, they're notorious for leaking, especially if they've never been used for years. When I turn it off and open it up, they're just notorious for leaking. I don't know any other word to say it. But now if this is leaking and I have to replace it, the only place I could turn the water off to this house is out in the street. And I need one of those Buffalo box keys in order to do that. So I would have to get the water department out here or a plumber that has one in order to shut that water off and replace that valve. Ball valves, don't get me wrong, they do leak, all right? But for the most part, I have a lot more confidence in these than I do any one of the gate or globe ones. Then we work our way to the water meter. In our area, it's very common that they put tamper wires. And if you look pretty close, I thought this one was cut, but you could... Yeah, I'm not just really seeing it. The only thing I'm seeing on this one is the cable that is for the meter reader from the outside. But typically there's a tamper wire. Just by the off chance, maybe about 10 years ago, 15 years ago, I just saw one that was sticking up and loose, and it was cut. And it just caught me by surprise, right? So then all of a sudden I started looking at these tamper wires on every inspection. And I got to say, I was actually surprised that I've been finding maybe 10, 15% of them that are actually cut. And something needs to be, that could end up being a $500 fine. So with a lot of these communities, to me, that's a big deal. So I usually advise my clients when I see those tamper wires cut that they contact the local water authority and let them know that it is. I know there's some communities, like Northbrook, for example, where I used to work, they don't put the tamper wire in anymore, and they don't put that tag. But Wilmette, where I live, we just had a new water service put here. Sure enough, the tamper wire's on there, and there's a nice tag on it that says this is a $500 fine if you remove it. People do keep the original pipes, and they can take that water meter off if you got a shut-off valve on both sides. Put the new pipe in there, and you're not going to be paying a water bill for a while. Now, please don't take what I just said as me encouraging you to steal water. We don't want to do anything illegal. But we also don't want to be accused of doing anything illegal, nor would we want our clients to be accused of it. So we'll bring it to their attention, let them know what it is, and whatever decision they do, they can do from there. All right, so here's our big famous warning. Don't turn on or off a main water or any shutoff valve whatsoever. They leak. That's the bottom line. You're not going to want it to leak. They're going to leak. And the finger's going to be pointing at you. So make sure that we get everybody clear, all of our clients, real estate agents, everybody know. Valves are there for an emergency. And it is common that they leak. We're not going to go ahead and create a problem by testing these valves and finding out if they leak or not. If somebody else wants to do it, let them do it, but it's not going to be done by me. Supply lines. So again, they're copper, plastic, galvanized. Those are pretty much the most common ones. I don't think we use too much lead for our supply lines in the house. So we talked about service. Now we're going to talk about supply. Again, this is the stuff that's after the water meter. Black iron, that's typically used for gas pipes. We really don't want to be using iron. It rusts, it corrodes, it's pretty bad. I've seen this rarely on galvanized homes. Somebody must have had a leak, or maybe it was corroded real bad and they replaced a section of the galvanized pipe. They didn't know better, so they purchased black iron fittings, black iron pipes, and since everything's screwed together because it's the same pipe thread, they figured that it was okay when really it isn't. All right. Galvanized has been common, even though it rusts and corrodes to the inside. It does have the same threading, but that's something that's been time tested for a long periods of time. But it does have a shortened lifespan. That's 60 years. This is a water supply line, and you can see the black pipes on there. Those are the black iron pipes, where the more grayish ones are going to be the galvanized. So cast iron, black iron, and galvanized, those all corrode from the inside out. So when I start seeing circles and rings like we're seeing on the galvanized pipes on these here, that's an actual leak. All right, it corroded on the inside. That's where it's the worst. And now it's working its way to the outside. Even any sort of stalactite or stalagmite, any sort of dripping that I see there, even if it's dry, the only way for that dripping to get there was for water to be there. So it's common that they'll start leaking like a little pinhole leak, and then they self-seal and they stop leaking. And then they'll leak again, then they'll stop leaking again. It's very common. I have never tried this to see if it's true, and I don't have the nerve or guts to try it to see if it's true. I just tell people, and they tend to believe me like I believe the person who told me this. But when I see stuff like this on here, if I take a knife and I start scraping at it, it's pretty much guaranteed that I'm going to be able to make that leak. All right. So it's not something that, we want to put our hands on and start rubbing and see if we can clear it away to see the condition of the pipe. Once we clear it away, it's going to probably be leaking. All right. So I would avoid it. When I want you to get out of this slide, galvanized pipe, black iron pipe, they corrode from the inside out. And this is what it looks like. Copper, I don't think it's in the test that you have to know which pipe is the thickest and which one is the thinnest where it comes to it. For me, I remember it by remembering Martin Luther King. All right. So MLK, M is the thinnest, K is the thickest. I would like you to know the difference between hard temper and soft temper. Most plumbing that we see with copper pipes is either going to be type M or type L. Most underground stuff that you're going to see is going to end up being type K. That's the thickest, and it just can hold up to the most amount of stress. Inside supply lines for copper everything is pretty much hard temper. If you start seeing soft temper where somebody's bending water lines, and I'm talking anything other than like a refrigerator ice maker line, those are typically soft temper copper, so people could feed them through the walls and stuff. But, we're not supposed to take anything soft temper through the walls. But anyway, so it's flexible so that the refrigerator can move, all right? But yeah, inside the house, only hard temper, so it shouldn't be bendable or flexible at all. PVC, CPVC, they're both plastic. They're both designed for potable water. Excuse me. Potable water is, I like to remember the term potable. Somebody from the military said that's exactly where the word came from. You're able to put it in a pot, but it means drinkable. Both of these pipes are for potable water. The only difference between the two of them is going to be what temperature that they're rated at. And yeah, so it's 200 psi, 3/4 inch pipe on the PVC. And I do believe the CPVC is also 200 psi. They are both for drinking water. But I know the CPVC has a higher temperature rating than the PVC. And let me look at the bigger screen here. 200 psi, 23 degrees Celsius, where the CPVC, where's my 400 psi at 70 and 100 psi at 180 degrees. All right, and I don't know where 23 degrees Celsius comes into play on it. I know 100 degrees is 212 and 0 is 32. So that's got to be somewhere in the middle there, obviously, someplace probably around 100 degrees. But since water can be hotter than that, we're not going to use PVC for our hot water lines. You can use PVC for cold water lines, but not hot water lines. Most of the area around here, here being again in the Chicagoland area, we're going to be metallic pipes. There was a time frame where the Illinois Plumbing Code did overrule all the municipalities. I want to say it was like around the 2000s. And even Chicago, up until the end of this year, I think. Or was it the end of last year? No, it was the end of last year. So January 1st. City of Chicago was actually allowing PVC and CPVC in the plumbing. They were doing a test program with it. So you are going to run into these items, and it doesn't necessarily mean that it was against code or somebody tricked somebody or did something wrong. I know other areas further out, these are just very common to see in there, and there's really no problems with it unless the water freezes. But the same thing, whether it's copper or plastic, they're both going to be weak when it comes time to freezing water. I think the only piping that I'm aware of is cross-stitch polyethylene or PEX pipe, where that will expand enough that if the water does freeze, it actually won't burst the pipe. Water won't flow, of course, but you're not going to get a broken pipe out of it. With the copper, CPVC, PVC, these are all going to break, and then once that ice melts, you're going to have water spewing all over the place. This is just the basement of a residential building. You see the pipes are white and plastic. Those are PVC. They're using them for the hot side, and that's where our problem comes in. Fine for the cold, not so fine for the hot. All right. Polybutylene, is what we're looking at here. Both comes in stiff and the bendable stuff or the flexible stuff. The only time I really see this being used is on like lawn sprinkler systems. And even that around here, a lot of people still like to go with PVC for their lawn sprinklers. The connections that they had with the polybutylene and ethylene, where the plastic starts to break down and becomes soft, rubbery, is where the temperature rating comes from. All right, Mark, I'm going to put that up on the screen. I think that's a good ad. And, Mark here is pointing out where the plastic starts to break down and becomes soft and rubbery. And basically, it's at its failure point. And that's where the temperature ratings come from. All right. And we don't know how long it's going to take them to do one thing or another. But this is a good ad. Thank you for putting that on there. And just so everybody else can hear this, Mark is turning into my favorite person today. All right, but don't tell him that. All right, where are we at here? Now, polybutylene, there were some class action lawsuits on this stuff. Something to do with the chlorine that was being put in the water, and that chlorine was reacting with the fittings on these things. I know I messed with this a couple times putting them together, and you almost need an actual blueprint to go ahead and figure the order of operations. I mean, once you figure it out, everything's nice and easy, don't get me wrong. But putting these things in the different pieces in the right orders and the washer in here going in the right different direction, if you got one of these things backwards or put in wrong, then that fitting is going to leak. The good news is it's going to leak right away. And then you're just going to end up, messing with it and putting it in right until you can get it to stop leaking. But I would do a little bit of research on polybutylene and class action lawsuits with it. I think you're going to end up finding it somewhat interesting. All right. Types of valves. Let's see here. The first one is a ball valve. They're calling it a ball cock, but we just refer to it as a ball valve. Those are typically quarter turns. When the eye is in line with the water pipes, the water's going to flow. Those are adjustable. So you can go ahead and, feather the water flow that comes in there. Gate valves, or let's back up to gate valves. Yeah, those keep it there all the way on the right-hand side. Those are really designed to be fully open or fully closed. I got nothing that I can back that up with, and I've done some research, to find out why this is. And I have no history or experience. But from what I'm getting or gathering, whenever you slow that valve down, you ruin that gate that's in there. And once it gets wedged or twisted in some which way, and that damages it. But again, I have absolutely no proof to that whatsoever. Both the ball valves and the gate valves, they pretty much can go any direction. All right, it doesn't matter which way the water is flowing on those. It's not going to matter. The globe valve, however, it does matter, all right? And even though they say that you can adjust the flow of water on these things, as far as I'm concerned, they're probably the most problematic valve you can ever put in a house. And what's kind of weird is like every water spigot that's a frost-free spigot, those are a variation of a globe valve like this. So where that black piece is, that's more of a rubber washer that's flexible and bendable when it comes in here. And as I open it up, now this water is supposed to be flowing from left to right as we're looking at these diagrams. And as I open that up, the water is going to go up and keep pushing that valve upwards, and then it would work just fine. What happens if somebody puts this in backwards, and there will be an arrow on the outside of these things, which does show the water flow, which way it's supposed to go in there. So we can check for that. But now if the water is going the other direction, and I keep forgetting that I'm reversed on the camera. So the water is going the other direction. If that valve isn't open all the way, then that water is going to keep hitting that valve, and we're going to end up getting water hammers. And again, it's going to sound like machine gun fire. You're just going to hear boom, 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 boom. And what it is that valve just constantly opening and closing as the water pressure keeps changing and going back and forth. So if it's in the wrong way, you got to get that thing all the way open. I think you're going to find that when you open up sprinklers on the outside, and I'm talking about the valve itself, they're switching those over to be quarter turn valves now for all the newer ones. But in the old ones, we had a whole bunch of turns coming on them. And as you open them up, you start getting that water hammer or that vibrating. And that'll continue until you open it up all the way. I'd like you to know the term cross connection. This actually used to be one of our mandated defects that we had to call out in the state of Illinois on our SOP. And I think it's a big deal. All right. I know that the chances of something happening are minute, but the cures are actually inexpensive and simple that we can do it. So the term cross connection means that there's a possibility that our drinking water, or let me back up, any wastewater can be siphoned into our drinking water. So if we look at the left-hand side, we see a garden hose and a puddle of water. Once that water leaves that spigot and enters that garden hose, it's wastewater at that point in time, all right? We don't want that water ever being able to come back into our potable drinking system and go elsewhere where I could drink this, through a cup of coffee or something else, all right? We don't know what's in that lawn. It could be pesticides. It could be fertilizer. It could be a whole bunch of other stuff that's in there. We don't want to draw that back into our drinking water and get somebody sick. So what we can do, and on the right-hand side, they're showing the spigot below the flood rim in that tub. So as I fill the tub, it's going to be filled up with water. Now, if those valves are open, and let's say, again, the fire department comes by and the driver of the fire engine wasn't paying much attention, or maybe somebody else hooked up to it as well, and they can actually create a negative pressure in those water lines. All right, it is possible for that to happen. In fact, it happened to me a couple of times. I'm pulling off of one hydrant and then another engine hooked up on a different hydrant, and he basically stole my water. So then as I'm trying to draw water out of it, I'm going negative. Anybody that had water spigots open in their houses, I would actually be taking all the water from their houses and bringing it into the water system there. So it would be siphoning. In this case right here where that tub is, if that was happening and that valve was open, I would actually suck all that soapy water and dirty bath water. I would suck that back into that pipe where somebody could use it again at another time. So, how do we prevent cross connections? The best prevention is going to be with an air gap. All right, so some sort of a opening. If I fill up that funnel with water and I just keep filling it up, that funnel is going to overflow. All right, there's no way that water is going to get high enough so that that pipe that's above it is going to be in the water, and then I'll be able to siphon from there. So any sort of an air gap will always be our best defense against any sort of cross connections or siphoning of our water system coming in there. If we don't have that ability, so here we're showing our tub again, we have that cross connection on the bottom. They do have anti-siphon devices that you can install in the water system itself. All right, so it's not necessarily the end of the world. So when everything's running and everything's pressurized, that cap on the right picture is pushed upwards there, and that keeps the water from escaping or leaving. However, if I create a negative pressure inside the pipe, so now everything's going backwards in that pipe, that seals it up, opens it up, and allows air to enter. And this way, air is going to enter the pipe, and we're not going to have to worry about any of that wastewater going into our drinking water. The same thing can happen with those garden hoses. These little anti-siphon devices, they I don't know, they're like $5 or $10. So even if I have an old faucet that doesn't have an anti-siphon, for a lousy $5 or $10 item, and all they have to do is screw that on the bottom of it, we take away even the most remote chance that we'll be able to siphon any of this water back into our system. All right? So I like to encourage that as well. These are the air gaps that are found in dishwashers and stuff. Nobody ever does this. I've seen pictures of them. I think I was in one house where I did actually see somebody install it this way. And it was with the Formica countertop. And sure enough, the countertop was damaged from water right around this thing. So the water comes out of those dishwashers so damn fast that it just sometimes it overflows these things. That's all there is to it. So around here, it's just been a common practice not to do it. But nonetheless, I want you to be able to recognize it if you see it. So the dishwasher goes up, it comes over the top. We have the air gap, and then it goes back into the drain that goes into the waistline. Typically around here, we're going to take our dishwasher and we're going to go and mount it or secure it to the top of the underside of the countertop. It's what we call a high loop. That's the common practice, not putting in one of these air gaps. Not saying there's anything wrong with it. All right. I want you to know the term dielectric union. Anytime we have dissimilar metals that are touching themselves, and dissimilar I mean aluminum, steel, copper, tin. Those are pretty much most of the metals that we deal with that are going to be an issue. None of those can touch each other. All right, there might be more, but none of those could touch each other. Now, there's also brass that gets used a lot in plumbing system. Brass is the only metal that could touch any one of those. So brass is a natural dielectric union. So if I have a galvanized pipe, galvanized steel, and I guess iron should be added to that list too. If I had a galvanized steel pipe and then I put a brass fitting on it, and after the brass fitting I go to a copper pipe coming in there, that's acceptable. That's the same thing as having a dielectric union. But if we look at this and we look at the breakdown of everything, we actually have a piece of plastic that's going to separate the steel and the copper. So those two pieces of metal will never touch each other. And the plastic is actually going to be our washer to get us a nice tight watertight seal. These fail. All right, I don't know what much more to say. If you find corrosion around this thing, that means that it did fail. And it does need to be switched out or changed at that point in time. Corrosion equals leakage. Anything that has ever corroded has leaked and will most likely leak again. It's not if, it's when. And we can't predict when it's going to leak again. Same thing with them touching on the outside. All right, so if I have a copper pipe being held up with a steel nail or resting on a ductwork, steel ductwork that comes in there, just by touching those two metals like that causes the electrolysis to happen. And the stronger of the two metals is the one that's going to start being corroded. Usually it ends up being, in this case, I think it ends up being the steel, or no, it's the copper is where it comes in there. But it doesn't matter. We're looking for all the corrosion, changing of colors and so forth when it happens, and we want to avoid any sort of leakage. Now, the cure of this, again, is simple, all right? I don't care what it is, cardboard, newspaper, anything that I can get a separation in between the two metals. Typically, somebody will put electrical tape on there. That works just fine. As long as they're not rubbing and we're going to deteriorate that electrical tape, that'll be just fantastic. But I've seen people put pieces of cardboard in there, anything just to keep the two metals from touching. And as long as they don't touch, then the electrolysis won't happen. Water hammers. So basically when water's in motion and then I hit the valve and I turn it off, that moving water is energy, all right? And it's kind of like if you take a garden hose and spray it at a wall, you can see that it goes off in all different directions. And when it goes off in all different directions, that's the force where it's changing. And that's actually pretty strong water. Usually we can even finite that and make it even tighter streams and build up power washers where it comes to it. So water in action and then channeling that energy or making it stop or making it smaller has a tremendous amount of force to it. All right, and we call that water hammering. So in this situation, what they're doing, they got a valve, we turn it on, turn it off. Every time that water flows and then we instantly stop it, that pressure is going to be like hitting a brick wall. So what we do is we have air, or in this case, we have a piston, a seal in a chamber. Since air is compressible and water is not, as long as I have a chamber of air, then that's going to go ahead and compression is going to cushion that stop, and that'll prevent the water hammering. If you turn valves on and off and all of a sudden you hear some rattling, chances are if we have a mechanical device like this, it's broken. If we have an air device, such as the one on the right, those get filled up with water. So the air does get absorbed into the water over time. It's normal. It does happen. Sometimes we'll see a whole house chamber as well. Those get damaged, and again, the water fills, or the air gets absorbed into water, and then the water level keeps rising when it gets up in there. Simple solution to those two is you just drain your plumbing system. So shut off your supply lines coming in or your service line coming in. Empty out all your supply lines. Open up all the valves so everything can escape. And then you go ahead and close all the valves. Turn your service line back on again. And what we do is now we added that air back into those air chambers. And we'll have that cushion come back for us. The mechanical ones, if those failed, the only solution that I'm aware of is replacement. I don't know if there's any repair to those. Now the whole house one on the far left, that's a little bit different. Sometimes those have an air hose at the top of them, so you can add air pressure to it. And that's pretty much enough on the supply system. So the next ones we're going to get into is the drainage systems. And then going back to the beginning of the supplies system, remember, even though I want you to know the 20 to 80 psi is, acceptable, I want you to know 40 to 70 is probable what we're going to end up seeing. I want you to know that under 20, you need a pump. Over 80, you need a pressure reducing device where it comes in there. We still work with functional flow. So I do want you to know the definition of functional flow, and this will keep you out of trouble. I can't tell you how many times that when we run the water and just the hot water only, especially in showers, you just get a ridiculously low water flow. You turn the cold water on, and everything looks beautiful again. But you're going to end up taking a cold shower there. That's the problem. And most people like to take a nice hot one. So when we're dealing with functional flow, that's water coming in. When we're dealing with functional drainage, that's water going out. And it's a simple rule. Anything should be draining water as fast as it comes into it. So if I'm in a tub and I got the water running from the spigot or the shower, and by the time I get to the end of my shower, I'm ankle deep in water, that's not functional drainage. All right. Now, if it fills up a little bit and then it holds it right there, that's still functional drainage, but it's most likely those lines are going to have to be cleaned. So waste piping, we refer to it as drain waste vent. Drains, they end up taking from the sinks, and that usually includes the traps. The waste lines are going to be our main plumbing lines that take away our solids and our water. And then the vent lines allow gases to escape upwards. Plus, they also allow air to enter the waste lines so that it prevents everything from creating siphons in our waste lines and allowing sewer gases to enter the building. All right, we'll go over those in a little bit greater detail right now. All right. So common materials, and we do have to describe the materials. Actually, this brings up a good point, too. We take on the term home inspector, all right? And in the state of Illinois, we have an Illinois plumbing code. And I do want to be very clear that only licensed plumbers are allowed to inspect plumbing systems, all right? We are not licensed plumbers. So technically, we're not allowed to inspect the plumbing system. Now, the Illinois Department of Financial and Professional Regulations, they realize that if we don't do something or look at the plumbing system and give somebody some sort of idea that there's a problem with it, that we're not protecting the public. All right, and that's their battle cry. Is all the licensees, their job is basically to protect the public. All right, so if we say home inspectors aren't allowed to inspect plumbing systems, well, that puts the public in pretty good harm should there be anything wrong with plumbing systems. So I'm going to do another one of these sessions on the SOP where we'll pull that up and we'll show it. But there's nothing wrong with you going there and reading it as well. What they did was they reworded it. And they say what we have to do is describe in detail the plumbing system. And that includes the supply lines. That includes the service lines, the waste pipes, the drains, the vents, everything else that comes with it, and issues that we find with those as well. All right. So what we want to do, and I don't know anybody who's gotten in trouble with this yet, nor do I think they will. I think the IDFPR will defend us for what it's worth. But if we know the rules, let's just stay within them, all right? So in our reports, let's try to avoid saying the plumbing system was inspected or, I couldn't inspect it because of this. Try to use whatever our state law says, which is that describe in detail. So we do have to describe in detail the materials that we're going to be using. Part of those is going to be, the drain piping, the waste piping, the vent piping. So typically cast iron, copper, PVC, those are the ones we're going to run into, all right? So the first one we're going to deal with is cast iron. This is showing a hubless connection. So there's no bell, no gusset. Typically, if I have to cut the pipes and stack them on top of each other, this is how I'm going to make that connection. Gravity is going to hold these things together. We have a community up in Lake Forest that up until like about the last 5 years ago, every waste line in that house had to be cast iron. Up to and including the trap for sinks, kitchen sinks, bathroom sinks, toilets, everything had to be cast iron inside that house. That was a waste line. Finally, it's gotten overturned, and now they're going to go ahead and let PVC come into play. I mean, as far as I'm concerned, PVC is terrific. But our biggest concern when we stack pipes here is these things sliding on top of each other. So what they do is they put a corrugated metal band around it with a rubber seal to keep it watertight, and then we put the compression clamps on it just so nothing can get away from it. But most of the time it's going to end up being a bell and gusset type situation. So we're going to have that bell that's going to hold the other pipe on top of it. It's going to sit inside of it. And then they're going to stuff the lower level of that gap with a waxy rope. And that waxy rope is called oakum. And then they're going to take lead and they're going to heat up that lead and get it into a liquid form. And they're going to pour that lead on top of the oakum in that gap. And that's what's going to make our watertight seal. Sometimes that oakum will start to boil, and then that'll come up and over the top, and it'll look like there's brown stains that are coming off of that gap, all right? And if you don't know what you're looking for or don't recognize it right away, I can honestly see how somebody would think that that's a leak at that joint, when in all reality, it's oakum, all right? Other than looking at it, the only other test I know to make sure that it's oakum is very sweet tasting. So if that's spilled, no, please, I'm joking. Don't taste the oakum. There is no other test. I apologize for doing that. All right, drain waste piping again. Let's move on. Proper pitch is important for good drainage. This is a test question. And I know one of our field houses that we had in the south suburbs, we were looking at waste lines that were going on almost a 45-degree angle. We had some of them that were going up as well. So the proper pitch is important. I do want you to know 1/4 inch per foot is the acceptable slope of this stuff. The blue that you're seeing in these drawings is water. The brown little pellet things is poop. And if you have it too shallow, the poop and the water is going to stay in the pipe. If it's too steep, the water will get through real fast, but it won't be able to wash the paper and the poop and everything else with it. That 1/4 inch per float or per foot, that's our happy space right there. And we'll have all the waste material flowing, and all the water will go ahead and get that out of the house where it comes to it. So 1/4 inch per foot. And we run into this with heating, with venting, and also with our plumbing waste lines. So the drainage, 1/4 inch per foot down. Our vents, 1/4 inch per foot up where it comes to it. So we want the warm sewer gases to go up, and we want the wastewaters to go down. Some other terminology, I'm going to ask that you take a few moments and write some of this stuff down. Anything that goes up and down is called a stack. All right. Anything that goes horizontal, we're going to refer to it as a pipe. Depending on what flows through that stack or that pipe gives it a few other names. If it's poop or solids of any type, such as what's coming out of the toilet, we're going to use the term soil. So anything that flows horizontal out of the toilet is our soil pipe. Anything that goes up and down and solids flow through it is our soil stack. The term waste gets used for water only or liquids only. So if it's a kitchen sink or it's only a slop sink or a laundry sink, those are waste lines. All right. So it's either a waste pipe or a waste stack. Anything that's horizontal is a waste pipe. Anything that's vertical is a waste stack. And then we also have air flowing through those pipes as well. Now, if it's only air, so these are the pipes that go up and out through the roof, those are going to be vents. All right. So typically it's going to be a vent stack. There is some configurations, and I'll show you some pictures in a little bit, where we can have a vent pipe coming in there, so it'll be horizontal run. But for the most part, we're going to be dealing with vent stacks. That means no solids are expected to flow through that pipe. No water is expected to flow through that pipe. Only air. And typically that's to let air into the system so that we would prevent a siphon from occurring on our waste lines and also on our soil lines. So as we look at this picture here, we can see the toilet on the right, and we have our slope going down and away. That's our soil pipe. The sink that's on there as well, that ties into our soil pipe. And then if you see the stack that goes up on that stack keeps going up and down so that where it lets water and air. So it actually has two purposes between the sink waste pipe and the soil pipe. That has a distinct name to it, and we're going to call it a wet vent. So it's designed to vent the toilet, let air come in there, break the siphon, but it still allows water from the sink to go ahead and go down there. Now, it's not the main vent stack. It's a branch vent, which is commonly the term that we're going to be using here. But in all reality, the part that goes up and down above the sink, that's our vent stack. And the part that goes horizontal up in the roof rafters or the ceiling joist, that's going to be our vent pipe. And then it goes into our vent stack that goes up and out of the building. Same thing here, just a little bit closer up to it. The wet vent, we're venting the toilet, and that's what we're assuming is present on the right side of that pipe where it goes. So if we allow water to come through it and air to come through it, that is a unique name of a wet vent. Cleanouts. This is common sense, kind of, all right? The sole purpose of these cleanouts is going to be to get a rod or a jetting machine or a rodding machine in there. In case there's a clog, I could get something in there and spin it and free up that clog. And this one's, roughly about 10 inches before I hit that concrete wall. And if I have to get that cap off and get in there and put a rodder in there, maybe a good plumber can do it. I don't know. But usually you want to give them at least 1.5 feet to do it. And they may never have to go into that spot, but that's definitely not a usable spot. Now, if I'm doing a home inspection and I see this, I cannot justify somebody making a change to it. But I might have a conversation where that if it does need to have happen and the plumber has to get into this one, there's nothing wrong with putting a 90-degree turn on it and bringing it towards us. At least that way it makes it accessible and usable where it comes to it. But I wouldn't do anything like that until the time comes that the plumber has to get in there. So I don't want to have the ownage on this one. I want to make sure that my client knows I saw it. So we're going to photograph it. We're going to document it. But this is one of those things where I'm just going to say, I just can't tell you to take any action or do anything about it. And if somebody disagrees with me, shoot out there. I'm cool with that. That's just my 2 cents. Here we got our galvanized pipe. We have cast iron fittings in there as well, going into our steel for our trap, and everything comes through. The problem with this one is, we're above the crown weir. So as we look at that stainless, I'm pretty sure it's stainless. It just might be thin steel on there, or yeah, it's probably just coated steel on the bottom of there, coated copper. But as we look at the bottom of that where it goes down and I got that U shape and then it comes over and turns towards the back, where it turns towards the back, that's the rear of the trap, all right? That's supposed to go straight into the wall. But instead it turns back up again and then it turns right and goes into the wall. So in all reality, that everything that's level with that pipe that's going out of the right, everything that's level with that is going to be filled up and held with water. It's just going to start creating problems with drains, low water flow, clogs, everything else that comes with it. We should try to get rid of the extension and bring it up there. But again, I think this is going to fall under, listen, I want you to be aware of it. I want you to know that it might be problematic. But, you know, as long as it's flowing and water's coming out of there and it's not siphoning, and I would definitely check it for siphoning. These are the ones that I get aggressive on. And what I mean by aggressive is I will fill up those sinks, both of them, and I'll get them at least halfway filled up with water. Then I'm going to pull the drain on both of them and see if they drain equally, A. And then when it's done draining, to see if I start hearing gurgling sounds. If I'm hearing gurgling sounds coming out of this, then I'm not venting properly. I'm creating a siphon. That gurgling sound is siphonage that comes out of there. And if that's the case, and I have the ability, and there is a possibility, I can't guarantee it will, but if I have the possibility that I could siphon out that trap, then I'm going to leave it open with air. And if I leave it open with air, I could get sewer gases coming into the building as well. And I think I would be remiss if I would be doing you a disservice if I stopped right there. You know, just because a trap gets siphoned out is not the end of the world. But we don't want to own it either. We don't want to be paying to have it done right. So we're going to talk to our clients, and we're going to let them know the worst case scenario. You turn the water on again, run it slower, fill the trap back up again, and this way we could prevent those sewer gases from coming into the building. I just want them aware that it could happen. Same thing with edge traps. You know, underneath sinks are big problem areas. I can't push it enough. And often I find that sellers of a home, they store a lot of stuff underneath the sink. And it may have leaked, it may have been damaged, and they'll just put either another board down there or they'll put a piece of plastic on the floor there. I know it's tedious. I know it's annoying. I hate doing it. But it's kept me away from a bunch of complaints because eventually it's going to happen. All right. Pull the stuff out of there. Look underneath any sort of plastic. Look for any sort of past damages and document it. I don't care if it's dry today or not. In fact, the state law says water damage, past or present, we have to document it. In this situation, look for it. Because when they move out and they take all that stuff that's underneath there and they take the plastic that's underneath there, and now our client moves in and they're going to look at this water damaged floor of this cabinet, and it's just going to be a punch in the stomach, you know, and they're not going to like it. But if we tell them ahead of time, it softens the punch up. It's easier to take that type of bad news, and even if you're not going to do anything about it, it's just easier to take that type of bad news when you're excited about getting the house. But after you're doing the moving, and any of us that remembers about moving, you're usually not in a good mood when that's happening. So when you end up seeing the damage to the floor, then it's going to be a few colorful metaphors, the word Charlie, and why didn't he tell me about this? So let's try to avoid that and be aggressive underneath the kitchen sink, bathroom sinks, anywhere where it's common that these things have leaked. All right. So here's a typical trap. I use the term crown weir. So it's this water that's sitting in this U-shaped part that's going to keep those sewer gases from coming back into the house. If this gets siphoned out or drained out or leaked out, then we're going to be open with air, and that's going to be able to get into the house. Now there's different ways that we create those siphoning effects. Some of them are rather quick and some of them take a long time. All right. Here we're showing different types of features or different types of ways to make those traps. I'm not a big fan of gluing a trap and making it permanent. I do like those screw fittings so you can take it off. If somebody does drop something in there and it gets caught at the bottom of that trap, simply unscrewing it, we could go ahead and find it at least. Otherwise, we're cutting pipes, damaging them, and then we have to repair everything when we come back in there. But it's still not the end of the world. I just want my clients to know if it's fixable or not fixable. All right. Sometimes we can use the soil stack as our vent, so we don't have to have an auxiliary. What we don't want to have happen is where our trap comes and it goes back up, and then on the top of that U where I'm going up, I don't want that to continue straight up to be my vent. It's got to make a turn, and as it makes a turn, then we want to go ahead and put the vent. Typically 5 feet is a decent number that we're going to run into for most sinks, all right? I found that if we're within 5 feet of a soil stack, and most of our soil stacks are going to be like right wherever the toilet is. They kind of keep them close to that where the bathrooms are. So if my sink and tub are within that range, I don't have to run a secondary vent or branch vent to it. You may. There's nothing wrong with it. Now, if you're suspicious and you're not sure if they got a vent there one way or another, especially like kitchen sinks by windows, and it looks like that they remodeled everything and just put in a new kitchen sink. This was another one that caught me by surprise, and my client called and they were not happy with it when they figured everything out. Now, it took them 4 plumbers in 2 weeks to be able to figure out that kitchen sink wasn't vented, all right? Whereas I had 15 minutes. So they weren't too mad at me, but they definitely wanted to educate me, and I respected it, I listened, and now it makes me a little bit cautious. So if I have a window over a bathroom, a window over a kitchen sink, and I try to be a little bit more aggressive around those areas. So I fill up the sink with water, I give it a good drain, and I listen for the gurgling effect. If I hear it, I'm going to call it out. If I don't, I'm not. But that's still not a guarantee. Somebody could have put an air admittance valve behind a wall. They could have done a whole bunch of stuff that we're not going to be able to see. But if we're too far away, then we're going to create those siphons, and that's where the problems are going to come into play. Double traps, we did see this on one of the houses that we did a field training on, I don't know, about 3 or 4 weeks ago before making this video. And they actually had the shower trapped, and then the shower went into the drain for the sink, which was actually trapped in the basement and not under the sink above. So the shower would trap, and then the sink would trap, and then that would go into the soils. So in a nutshell, even if I got an air brake, so the left sink is that air brake, even if I have that, then these are just still prone to siphoning each other out. So one will keep pushing while the other one's done. I've seen it in one house where we had the double trap, and I swear that gurgling lasted for, I want to say about a minute and a half. You just hear gurgle, stop, gurgle, stop, gurgle, stop. Now in this situation, because we have that sink that's in between there, that would probably stop the gurgling. But if that was filled with water and draining, that would get air being sucked into both of them, especially if the right side was empty. Then that would go ahead and gurgle. This is just a cool picture. Hopefully you're going, what the hell is that? And Lord knows I did when I first saw it. This was an 1800s Victorian home in Elgin, Illinois. And there was no way in hell that the owners of this home were going to allow this thing to disappear. This is a mechanical trap on it. It's not vented. It goes straight down into the sewers. The piece that's sticking out kind of like a cone towards us, that's spring loaded. As water gets in there, it pushes that in there, and then water continues to go down. This thing is probably 80 to over 100 years old, all right, as a guess. It's all brass. It's solid. You can see the green, maybe it's copper because of the green. You can see the green on the pipes. You can see the corrosion on the pipes. You can see the water damage on the floor and the tile and the wood that it's happened. So this thing is leaked. It's been fixed. It's leaked. It's been fixed. Obviously it's over 100 years old. I just thought it was cool, and I would agree that there's no way. But I'm still putting it down that my clients should expect it to leak, because I don't want them calling me and complaining if it does leak, and them being able to say that you didn't tell me that this was going to leak. So these are the problematic ones, things that usually end up causing clogs or causing them to be siphoned out for whatever reason. So starting on the left is a typical S-trap. Older homes, it was just very common. We never worried about venting all the sinks. We just vented the system when it came out to it, or the main soil pipes that came in there. But an S-trap, you can see how it goes down, up, and down. If I get enough of a water flow, that can create a siphon. And if I pull everything out of the bottom trap, then I'm going to let soil gases come into the house. Solution, turn the water on slowly and fill it back up again for a few seconds, and there won't be any smell. The middle one is what we call a crown vented trap. I kind of talked a little bit about this before, but now you're seeing a diagram of it. So the sink comes in from the right, goes down, and the vent goes straight up. We don't want that. We want it to go up more like the letter P and go to the left for a foot or 2 or 3. And then we want to get our vent in there so we can let that water get filled up, and then we can break the siphon. Drum traps, they're still putting them in today. I don't know what much more to say. I can't stand these things, plain and simple. I remember my first house in Elmhurst, we had a drum trap in there, and I still have nightmares over this thing. My tub clogged up, and realize I was a 24-year-old kid. I didn't know anything about plumbing at the time, so don't judge me for what I'm about to tell you. I'm just being honest, all right? And I had my bathtub. It was not draining right. It was clogging, and I didn't know anything more of it, so I went and I got one of those handheld rodders, that you crank from the Home Depot store. And for those of you that know what's going to happen already, you're laughing at me, and I don't blame you. You're like, oh, that's bad, and you're right. Oh, it's bad, So I put that in the pipe, and then all of a sudden it tied up in knots inside that drum trap, and I couldn't get it out again. So now it's stuck in there. And I'm like, again, a few colorful metaphors came out of there. So then I went around the closet, and in the closet was a piece of plywood, which was my access panel. And I opened that up, and I see the drum trap on there. Well, then the drum trap has a brass cap on it, right? And again, I was young, naive. I didn't know better, all right? So I go get a pipe wrench, and I try to unscrew this thing and get it off to see what's going on inside of it so I can figure out what the problem is and fix it. And it wouldn't budge, right? So what do? You go get a bigger wrench. So I went and I got a bigger wrench, and I pulled harder, and it still wouldn't budge, right? And I'm about an hour into this thing. I'm hitting it with hammers. I'm pulling on this thing. I'm giving it everything I got. Nothing would happen. So, I'm a smart guy for a 20-something-year-old. And I think I was still like a teenager. So then I said, well, let's get some leverage. So I had an old fence post outside. I grabbed that, slid that sleeve over the adjustable wrench, or the pipe wrench. And I got way out there, and I got that leverage, and I pulled hard, and all of a sudden the nut snapped off on me, right? And then I'm like, holy crap, now what do? I didn't figure it out. So then I'm like, I got to get that off of there. So I took a chisel, and I started hammering away, breaking it away, and shorten up the long story that there's no way I can get it any shorter than what I was just doing. I go to the store, buy a new one, and I find out that they were like $1.50 or $2. And I could have easily taken a Sawzall and just cut that damn thing and broke it in there and pulled everything out of there. Um, and I would have saved myself about 4 hours of trying to pry that thing off. And every time I run into these things now, I would never try to get it off. I mean, I get it, but I try to break that nut right away and then sawzall the cap and get rid of it. Then I had to cut the rotting machine, clear out all the goop that was in there, and then we had good water flow coming in there until it gooped up again. So sorry, didn't mean to bore you with that story. Hopefully you're laughing at me, but life goes on and I learn from my mistakes. This was in that same house that we saw the mechanical trap. Obviously, they've updated some of the plumbing, so you can see the cast iron going out to the street, and then we have a PVC pipe going up and to the left on there. They also had a building trap that I thought was interesting. Typically, we don't see that. We let those pipes, be a straight run all the way through the roof, so that if any sewer gases do come up there, we let them vent out through the roof. But the building trap in here prevented that, at least on that line. Obviously, the one that's coming to the right of it, and they did merge together. Sewer gases would still come up there. But it was kind of a no-brainer, when somebody puts duct tape around a pipe and a bucket underneath there that has water in it, there was a pretty good chance that it's leaking, and this one obviously was leaking when we came with it. Backflow valves, this drawing, and I think the picture on the next slide, are from areas of warmer climates, all right? So, and I'm not an expert in Arizona or Texas and stuff like that, but I don't believe they go as deep with their sewer lines as we do, all right? I think there's someone on the shallow run, so it's easier for them to fix things if they can get to them. But even with water or waste lines, there's been I want to say it was like the 70s or 80s, we had a whole bunch of flooding up in this area, and a lot of plumbing companies, when the sewers would back up into the houses, they would sell these backflow prevention things. Some people actually put big gate valves into them, and some people just had flapper valves that came up. Sometimes they went down, sometimes they went up, whatever. So the water would flow one way, and then if it was flowing backwards, the valve would close and stop it from coming up. All right. This is an actual one where you see it in the ground. Water's supposed to go in there. This one's hanging down from the top, so it prevents the water from going backwards and coming back into a house. Direct venting, I made that mention before. For within 5 feet, typically we're not going to have too much of a problem with it. Anytime you're suspicious of it, though, you should fill up the sink and give it a good drain and see if there's any sort of problems. You don't always know what's going to be behind the walls. I know there's more and more tools that are coming out there. I think there's this like Wallabot or something like that that attaches to your iPhone, and it's able to identify things that are behind the walls. I've heard people play with them. I've seen videos with them. They look pretty cool, but I don't own one, and I really can't verify for sure. So whether or not we're properly vented, air vented, branch vented, air admittance valve, we don't know. All right. So we need to make sure that our clients are aware that anything that is behind the walls, we're not going to be able to tell them anything about it. It may seem common sense to you. It definitely seems common sense to me, but you would be surprised on your client's expectations on what they expect you to know, what they expect you to do, and what they expect you to tell you. And if they think you're wrong, it's very difficult to get that back. You almost have to get into an argument with somebody about those expectations and let them know why it's right and what it's for. All right. This was kind of one of my favorite pictures that we took at one of our field training houses, and that they put, what is this, 1, 2, looks like 3 extensions, so I got 3 extensions on there, and it's still too long, so it's kind of like my old joke with the board. I cut it 4 times and it's still too short. All right, causes of broken trap seals. Most common cause we're going to run into would be a negative pressure or aspiration. So here they're showing a large flow of water from the toilet. We're not vented properly with the sink or the laundry tub or something else that's nearby. That's going to create a negative pressure and siphon out that water in the trap. Once the water's gone, then air is going to be able to come back up. All right. Next one is going to be gravity and speed that comes in here, or momentum, as it says in the upper right corner. Typically, we don't want to go more than 2 feet. I think the max, I want to say, is 30 inches. It might be 36. I'd have to look that up in the code books again to come with it. But 2 feet is going to be a magic number. So if you ever have a trap that's below the floor from an appliance above, I mean, if it's a shower and it's right up there, typically not too much of a problem. If it's a sink that's coming all the way down and putting the trap in there, you're going to be at least 2 feet at that point in time, and you're going to start having, some sort of issues coming in there. Laundry tubs, it happens, or laundry drains, it happens with them quite a bit. They're a little bit higher. So you might be at that 3-foot spot. The only way you're going to know something like that is happening is going to be sewer smells coming in there. And they're really, other than filling up a sink, there isn't a good way to do it. So just momentum, speed, or go ahead and do it. Hair is a huge one, especially if you don't use that appliance for a while. So if you get hair that's caught in the drains, and it doesn't necessarily have to be in the trap. It could be anywhere down the line. But that acts as a wick, and it'll just keep sucking the water right out of there, just like a lantern would lift the oil out of there, and it would just move it right over. Typically, you find this happening in vacant homes. Sometimes people think that it's because the water that was in there evaporated. It may be. It's hard to tell. But if you end up, when water in trap evaporates, if you tell them to go ahead and put vegetable oil or some sort of oil in there, that tends not to evaporate as fast as the water does. But if there's hair in there and that hair is pulling it up, that'll actually siphon out faster. So if you put the oil in there and the smells come back, chances are it needs to be rotted, jetted, whatever. Or if it's pieces that are replaceable, replace them. Something if you're going to leave it vacant for a long time. If it gets used a lot, it really doesn't come into play. S-traps, we kind of talked about that before. They create that siphon or that momentum. And if we get all the water out of there, then sewer gases are going to come back in here. Loop vents. These are for island sinks. There's a few different methods, and this is the most common. And this is what pretty much what the state of Illinois and all the communities around us want them to do. They get that loop up as high as possible because you're not going to be able to get past that island. And you're not going to be able to get past that island to go ahead and send a vent stack up. Sometimes people will cheat a little bit and they'll sneak an air admittance valve up on there. So when you're looking underneath the sink, we really should be seeing a couple different pipes there. And they may have one visible and one not visible. But if one does go up, do your best to get your phone or your camera, get that back in there, and then take a picture of the underside and just make sure we don't have an air admittance valve stuck in there and trying to shortcut. Those air admittance valves, and I'll show those in a little bit, they're kind of like an anti-siphon device, only, they're just designed to open up quicker and easier. They do fail, and if they fail in the open position, then we're going to end up getting sewer gases coming into the house. If they fail in the closed position, then we're going to end up siphoning out our traps and, again, getting sewer gases coming into the house. This is another way to do it, and it's really not acceptable in our area, but from what I understand, it does work. I have seen it. I have tested it. I have not been able to make it siphon out. So what we're looking at here is a sink and an island. We put our trap. We start off at 1.5 inches. And then every time we make a turn or every time we go a certain distance, if you notice, the pipe keeps getting bigger and bigger and bigger. So we go from 1.5 inches to a 2 inch to a 2.5 until we get to the soil stack. And as long as that pipe keeps getting bigger and bigger, we're not going to be able to fill that pipe up completely with water. So there's going to end up being air and water in that pipe. As long as we have air and water in that pipe, we're not going to be able to create a siphon. The air will flow one way and the water will flow the other. This is what an air admittance valve looks like. So whenever there's gas pressure or something coming in there and smells, it's going to force everything shut so that those smells can't escape. But as water is running and it creates a negative pressure inside the pipe, that cap is going to lift up, and then it's going to allow air to enter, so we're going to break up the siphon. And again, it's just pieces of plastic or whatever. Some of them are spring-loaded. They're sliding on top of each other. Moisture's going to be there. Corrosion's going to happen. Eventually, they're going to be stuck in either the open or closed position. There's not a lot of pressure to move these things. All right. If we do put it on there, it does need to be above the flood rim anyway. Or I'm sorry, here they're saying the trap arm. But truthfully, you got to get above that water line up in there, because if you fill that sink up, and let's say I have a little bit of a clog and it's not draining fast, that water is going to seek its own level, and it's going to push right up that air admittance valve, and the water is going to end up coming out of there, and they're going to end up leaking too. So the higher the better. Vent sizes when we come up to the roof. Typically, we don't want to see these 1.5-inch pipes or 2-inch pipes coming out through the roof line. They should be expanded to be about 3 inches. The only time you're going to see a narrow one is going to be a pre-World War II home, and it'll be for the kitchen sink area only. So it's just a waste vent or an air vent for a waste pipe. So there's only water that's going in there. The problem with that, and especially because there's always going to be humidity and moisture in those pipes. And if I'm above the attic and I'm not heated anymore, that humidity, that moisture that's going up there, and that's natural, it's going to keep flowing up, that's going to freeze. And when that freezes, it makes these big snowflakes, and it expands real fast when it freezes. That frost is actually has a specific name to it, and I'd like you to remember that name. It's called hoarfrost, H-O-A-R. And that hoarfrost, if it keeps going, it's actually going to seal up that vent, and we're not going to let the air flow anymore. And if we don't let the air flow and we're not vented, then we're going to start siphoning. That air is going to come into those pipes. It's going to come in from somewhere. If it can't come in from the roof, it's going to come from our traps that are in our plumbing pipes, and we're going to siphon those out, and again, sewer gas is going to start entering our building. Common sense stuff, we don't want to put a soil stack next to a window. This happened to be in Elgin as well. We were doing field training out there, and this was not the house that we were inspecting. This was actually the neighbor's house, and down below they put that addition on, and they put a bathroom in the addition, and instead of going to the left or the right of that window, they just went above the roof line and stopped it right there, and that would be it. And, I mean, common sense, somebody uses that toilet, you're going to have smells come out of there. If anybody has that window open, the smells are going to come back in the house. And we can giggle about it, and I get it, I would too. But in all reality, it's not healthy. You don't want those sewer smells coming in here. So there are some numbers. If you are taking notes, and I hope you are, these numbers that are written here in that box are important. You definitely want to get those written down. So 3 feet above a window, 12 feet from doors and windows, if it's on the same level. All right. 6 feet from the property line, 7 feet above a deck, and 7 feet above the ground. All right. So if I have a deck on this roof, it has to be 7 feet higher. I see that a lot in Chicago. I mean, a lot in Chicago. People put these rooftop decks on, and the plumbing pipes go up there, and they just build right around the plumbing pipe, and they leave that small pipe there. They don't extend it to be 7 feet higher than their walking surface. And I guess if you're outside and you know what's there, you're going to live with it. But, yeah, living with the smells, they're used to it, and it's no big deal. But realize it's not just when somebody uses a toilet. That pipe goes straight to the main sewer line. So it's not just this house. It's every house in the neighborhood. Whatever sewer smells are in that main sewer line are going to come up everybody's vent stack. And if that's someplace where you're sitting and you can breathe it, again, I think it's unhealthy. And we should be extending these up higher. All right. So water heaters is going to be our next subject. Let's keep pumping along. All right. A lot of different parts. I think I'm going to take some of these slides too and post them so you could download them and get nice big pictures of them. You should understand how a water heater brings in there, and you're going to be beaten up. Let me just back up a little bit. I hear so many people call these hot water heaters, and plumbers will beat you up, other home inspectors will beat you up. There's no reason to heat hot water. I understand it's a habit, but it is a water heater and not a hot water heater. If you want to say it's a cold water heater, then go ahead. All right, enough of that. I want you to know how they work, though, and how they get the best use of the water that gets heated up. All right. So knowing all the different parts that comes with it, and what we're looking at here is a gas unit, and how we heat up the water, I think is vitally important. So we'll start at the top. All right. We have a red line and a blue line. So hot on the left, cold on the right. The blue line brings the water in. Usually we only need one isolation valve on a water heater, and that's going to be on the cold water pipe. And again, as you're at the front of the water heater, that isolation valve should be on the right pipe, or the right side pipe. Left side is the outgoing, that's the hot water. I actually like it when they put an isolation valve on the hot water as well. If for some reason you need to remove the water heater and replace it, we don't have to drain the entire house to make that happen. So everything is still usable. Just not the hot water would be flowing, but we don't have to drain all the water. So as the cold water comes in, the cold water pipe, we're going to drop down to the dip tube. All right. So you can see the blue water line goes towards the bottom of the tank. So as cold water enters the tank, it's going to enter at the bottom. Naturally, heat rises, so it's always going to be the hottest at the top and the coldest at the bottom. So as long as the hot water is leaving through the top and the cold water is entering at the bottom, we'll be able to use the vast majority of the hot water in that tank. It won't churn, it won't mix, it won't try to equalize out as long as that water is flowing and we're taking a shower. So we'll get the best use out of it that way. Now these dip tubes, that blue pipe that's going down to the bottom, they're fragile, all right? And they do deteriorate, they do break. And if they do break off and it's gone and it's sitting inside the tank, we're not going to see that and we're not going to know it. What's going to happen is that now cold water is going to be introduced into the tank at the top. So that cold water, it's kind of like electricity. It's going to take that path of least resistance and it's just going to flow straight from the right side over to the left side. And we're going to be running out of hot water in a matter of a few minutes. The tank will be filled with hot water. We're just not going to be able to use it because as the hot water is leaving, it's being replaced with cold water at the top. And the wall of water and the rest of the tank just is sitting there. It's not doing anything. So that's what the dip tube is for. Bring it down to the bottom. All right. Going back up to the top. Let's skip over some of the venting. We're going to stick on the left-hand side. All these tanks do have insulation built into them. They're typically about an inch and a half thick of either fiberglass or foam insulation. The newer ones, the Fleurs, they're actually going to have an interior wall where air flows through there as well. All right. The next item going down the list I want to focus on is the sacrificial anode rod. On the left-hand drawing where it's open, that's the rod, the silver rod that goes about halfway down into the tank. All right. Those are going to be made out of magnesium. Some of them are made out of aluminum. I keep forgetting which is which. Some of them are designed for well water, and some of them are designed for city water, where it comes in there. I always have to Google it for some reason, and every time I Google it, I forget it about 5 minutes later. So we can do it again at the end of this, but for now, I'm just going to ignore that. This water that's inside these tanks will eat away at the metal. All right, it's going to cause the water tanks, even if they're glass lined, to deteriorate as time goes on. The purpose of this anode rod is all the chemicals that's in the water, instead of them attacking the actual tank themselves, they're going to be focusing all their attention on the anode rod. And they're going to eat away at this anode rod until eventually it's gone. All right. Now, you can replace these anode rods. The manufacturers recommend that you replace the temperature pressure relief valve and the anode rod every 5 years, and that you flush the system. Don't drain it. You just want to get that water flow out of the drain valve at the bottom. You flush the system once a year until clean water comes out of there, and that way you get rid of all the debris. But yeah, those anode rods get eaten up, the pressure relief valves get eaten up, and to keep them living long and keeping a water heater, and I know one guy who's a water heater fanatic. He's got a 7-year water heater, and I think it's going on 50 years right now. And that's what he does. He just changes out that anode rod and that pressure relief valve. And they do sell hinged anode rods and thicker anode rods so that you can slide it in there and another piece will go in there and you can get the whole thing back in there and tied up on there. I think it's Water Supply Warehouse in Northbrook. And he's a flutist too, and I can't think of his name offhand. Loves to talk about water heaters. I mean, talking about a guy with a passion, he's phenomenal. And you could call him up on the phone tomorrow and chat with him. If he's free, he'll talk to you about water heaters and how he helps Ream and everybody else write their manuals and what's dangerous with them and safe with them and so forth, and how to keep them lasting forever. Not a big fan of the tankless water heaters. He likes these tanked ones. But again, changing those anode rods, changing the pressure relief valves is huge. We work our way down. Let's go over to the gas pipes here. So we do have a gas valve. We do have our gas pipes. We do have a drip blade coming in there. I think those are somewhat self-explanatory. The burner is at the bottom. If we look on the left side of the picture, that's going to create our flame, heat up the bottom of the tank, and then those hot gases are going to go up the center flue. They're going to go up the center flue, they're going to go up the center flue of the pipe until we get to the vent connector. Inside the flue of that water heater is a baffle, and it's nothing but a twisted piece of metal. So as the hot air goes up, it's going to bounce left, bounce right, bounce forward. So it's keep pushing the heat to the different sides of the walls as it's going up. And that just helps heat the water faster. It gives more direct, not necessarily flame content or contact, but heat contact when it goes up there. Once it gets past the top of the water heater, then we want to induce fresh air with it. We want to bring that temperature down. Typically, you're going to be exhausting somewhere around 300 degrees of heat from the top of a water heater. And I'm talking about after, I'm talking about before the draft to it. Afterwards, it'll drop down to under 200 or 200 degrees once I get 70-degree room air mixed in with it. I think that summarizes our water heater. So hot on the left, cold on the right. We want to have a pressure relief valve on it. Pressure relief valves, numbers that you should be aware of. They're designed to open up and stay open, and we'll show that picture in a little bit, at somewhere around 210 degrees. They're also designed to open at 150 psi of pressure. And what's weird is in order for me to get to 150 psi of pressure, I got to get that temperature up to 300 degrees. So not always do the temperature pressure relief valves open, and it may just be a pressure relief valve and not a temperature pressure relief valve. You would only be able to tell that on the data plate. This next one is an electric water heater. We still have anode rods in them. We still have pressure relief valves in them. Excuse me 1 second. My favorite. See if I can move this to a spot where we can read it. If you don't drain it periodically, then there's a chance for hot water to get trapped at the bottom under the debris. Absolutely. You're talking about the gurglers, aren't you? You know, when that pocket escapes, it could trigger too hot of a warning that will shut the water heater off. And one of the, that is a great ad. Thanks, Mark. One of the things to put on that note too, and something that gives you that clue that that's happening, we call those gurglers. All right, so when the water heater is heating up the water and the flame is going, and you start hearing this gurgling sound coming out of the water heater, that's water underneath the debris that's there, and it's turning to a steam, basically. It's boiling, and that's lifting that debris up and dropping it back down again. That creates that noise. So you got a lot of debris in there at that point in time, and it's either time to flush it or you're going to be looking to replace it. Great ad. Thanks, Mark. With these electric water heaters, we don't necessarily need a dip tube. We don't bring the water in from the top. If you notice, the cold water line is actually just plumbed straight through the outside and comes in through the bottom anyway. So we're not worried about finding that dip tube. And as we go up and out, the hot water comes out of the top. So we're doing the same thing that we were doing before. Bring the cold in at the bottom, hot at the top. We have two heating elements on these things. Don't take the caps off and try to look inside of them. These things are dangerous. There are 220 volts of electric that comes in there. You don't know when they're going to turn on. I can tell you that they do only turn on one at a time. Our next slide. Yeah, so they only turn on one at a time. When the cold water enters and the hot water is pushed out of the top, then it's going to try and recover as quick as possible. So if only we have cold water on the bottom and warm on top, the bottom one's going to go. All right. Once I run out of hot water in the entire water heater, then it's going to recover the top half first. So then only the top element's going to be ignited. Once the top half of the water heater is heated up appropriately, then it's going to turn the bottom one back on so that it'll get the bottom one heated up. And then, of course, when everything's at the right temperature and it's equal, it's going to leave everything at rest. I got to remember to keep putting these questions over on the screen so everybody can see them. Mark was asking me again, why a dip tube on the gas but not on the electric? Yeah, I'm not the expert in designing. I got to make up some assumptions on here. I think a lot of it has to do with the room and the space and the fragility of the dip tube itself. So what we don't want to have happen is for that dip tube to break off and fall up against these electric heaters, all right? If we did that, then we would be creating a direct short in the energized portion of the electric burner or heater and the ground if it falls and leans on it. I think that's why they avoid the dip tube on that. But even with the gas water heaters, I mean, in all reality, it does seem like a smart idea. Just pipe it from the outside, do away with the dip tube altogether, and now you don't have to worry about that dip tube breaking off on the inside. Great question. But that's the only answer I got. Is I don't think they want to take a chance of that dip tube falling off inside and hurting the or energizing the tank itself. So this one we kind of saw before. It's a repeat. Next one is going to be an oil burner coming in there. When we talk on heating and we do the heating systems, you are going to be expected to be able to identify if a heating system is an oil burner versus gas versus electric, whatever the different fuels are going to be. So typically with the oil burners, they're going to be, a regular pump like this where it's going to pump in air pressure. It's going to pressurize the oil itself. It's going to create what's the term that they used for that? Atomizing. So it's going to take the oil and it's going to put it through a fine mist spray, and it's called atomizing the oil because it's pretty much just a surface area that's going to ignite. So it needs to have a spray of oil as opposed to a stream of oil coming in there. and that just burns cleaner and nicer when it comes through it. So we have to pressurize the oil, pressurize the air, because I need to have that oxygen mixture in there, all right, when it comes through it. But I still have the same baffles, same dip tubes, same anode rods, same pressure relief valves. Something that is different, though, is I don't have a draft hood at the top of it. So with gas appliances, we're going to allow that mixture of fresh air to be taken in through a draft hood. Because oil burners are not as consistent as gas burners, they need to have something that's going to vary how much air gets mixed in there to cool the temperature off. So in this case, they're going to use what's called a baffle, or a barometric damper at the very top. Kind of looks like the old Napster logo if you think about it. That's actually on a hinge, and that's going to open. So the hotter the air is, the faster the air is going to move. The faster the air moves, the lower the pressure will be inside that pipe. The lower the pressure inside that pipe will cause that valve to open more and let in additional fresh air, slowing the heat speed down until it gets to that happy medium. So we get that flame or that heat speed going through the baffles and the vent and the flue. We get that all through that barometric damper that opens and closes. Water heaters, we do look at the data plates on these things as well. Buildingcenter.org. I know I made mention of this site many a times. I have it memorized and bookmarked on our phone. Whenever you want to try and find out when something was manufactured, then that's the best place to go. Water heaters are typically going to have an ANSI code on them as well. So if we look underneath that star, the American Association, the NRTL design up there, when we look underneath there, we see 1998. All right, so that's the code that this water heater was manufactured under, was the code of 1998. Now, codes typically go for 3 or 4 years in that ballpark. So just by seeing that ANSI code, I know that this thing is going to be anywhere from 1998, 1999, year 2000, or the year 2001. All right. Next thing I do is I look at the serial number. Most of them are going to end up being, the first letter is going to be our month code, and then the next two numbers is going to end up being the year of manufacture. So A, B, C, D, E, F, G, H. H is 8. 8 is August. So my guess is this would be manufactured August of the year 2000. And even if I was off, I'm still damn near close. So depending on when it was manufactured in today's date, then, that's where it is in its lifespan. We usually tell people 15 years on a water heater. I know some of them are at 7, some of them are at 30. We like to stick to one number right down the road and figure out where that water heater is in its lifespan. Clearances for water heaters, this is more common sense. I really don't know if it's set in stone anywhere, but you're going to have to replace that water heater at some point in time. And I think we should give consideration to how am I going to get it out of there. And when that water heater gets replaced, it's going to be filled with so much crud and you're not going to be able to drain it. That thing's going to be heavy as there's no tomorrow. It is not an enjoyable thing to do. You're going to need a couple of young people. So 2 feet is pretty much a good amount of room. But if it was less, I think I might make mention of it. But I can't tell people to move walls, appliances, water heaters. It's just not in me to recommend that. So, dip tube we talked about brings the water down to the bottom. If it breaks, then we end up getting short cycling on everything. Anode rod, we kind of chatted on that as well. That's designed to be eaten away before the water heater gets eaten away. It always reminds me of somebody's first day on the job. I always recommend that they bring in donuts. And they go, well, why do I have to bring in donuts on your first day of the job? And then I tell them, you feed the animals before they eat you. So same thing with this anode rod. Let's let the bad stuff eat the anode rod before it eats the water heater. Temperature controls. 120 is kind of our magic number for a safe range. And again, this is all how much risk are you willing to take. For us, we shoot water flow with the thermal imagers so we can take a temperature of that coming out of there. But I'll openly admit, even my water heater here is set at 140 degrees. So water that's coming out of our spigots, our faucets, is going to be 140. 20 degrees over the safe range on that. But I don't have any infants, and I think I am the elderly person living in this house. So, those are going to be the two people that are going to get harmed the most, and I'm willing to accept that. Although I will be honest, I mix it with cold water anyways, so why not just leave it at 120? It is a tankless water heater. I think that also means that my cleanup will be less as well, or my flushing would be less often if I left it at 120. But everybody else in my house likes it at 140, so that's where we leave it. But realize it does cause burns. I think I will put this chart up on there too. I think it's useful. We got it from the Shriners. And different temperatures on different skins. And it's amazing how fast at 140 degrees you can burn a baby's skin, in just a matter of seconds. So I don't know what much more to say. So first degree burn is a sunburn, just the surface. Second degree burn, you start getting blisters. And third degree burn, you burn all the way through the skin, and you basically have to replace the skin or wait till it grows, or get it to grow back. It is permanent tissue damage. So contained water will create 150 psi at 300 degrees. One of my favorite shows used to be Mythbusters, and they actually blew up a water heater by disabling all the safety features on it and keeping it getting hotter and hotter and hotter. I think they got it up to about 315 degrees. Don't quote me on that number, but it was damn well right in that ballpark. And then finally, all the liquid wanted to turn to steam, more so than what the vessel or the water tank can hold, and it exploded like a missile, and it just tore the house down. So a rupturing tank, I do want you to know this term too. It is an acronym. It's called a BLEVE, and it stands for Boiling Liquid Expanding Vapor Explosion. All right, a BLEVE. I'll back up real quick. Well, we'll just talk about it. When that, I have seen it once, where a pressure relief valve opened up, and was allowing all that steam to enter the building. It was at a downtown florist shop in Northbrook. The shut-off device, so the flame was on, it's staying on, kept getting that water heated up, so much so that it released on the pressure relief valve, and the entire room that this water heater was in there, and it must have been probably a 50-foot by maybe 100-foot, was filled with steam, and that steam set off the fire alarm. So we responded, we go in there, this room is filled with steam, I hear the steam going, and I was able to see down low where it was, that it was the water heater, and we just went there, we turned the gas off to the water heater, and then the pressure relief valve finally closed, everything cooled down, and the problems went away. All right. But I would like you to get an idea of how these pressure relief valves work. All right. In a nutshell, there's two different devices. It depends if it's a temperature relief valve or a pressure relief valve. So the temperature relief valve, that's that wax fill. We'll go to the bottom picture first. That wax fill that's there, they have different colored wax that gets in there depending on where this thing is going to be set at. And when that opens, it stays open. So the wax changes size, opens the poppet valve, and then water will continue to flow coming out of there. Most temperature pressure relief valves for water heaters are set at 210 degrees. So we would never get to that boiling point where it is. The pressure, which is that spring loaded on the poppet valve, that's going to open up at 150 degrees for a water heater. Now it is less they do have smaller ones that open up at lower pressures, but typically those are for hydronic systems or steam systems. Water heaters are 150 psi. I do want you to remember that number. Now, if it gets corroded inside that, and you can see where the spring and the mechanisms of the poppet valve is on there, if that's corroded in there or it starts to leak, and whatever you do, don't lift that lever up at the top there, because yeah, you can lift it and you can open it manually and you can get water to flow out of it manually, but they just never seep back. All right, there's always going to be some little piece of debris, something that's going to give it a slow leak, something that's going to create a problem, and that water slowly leaking through there will create that corrosion. What I would like to encourage you to do is spin it, and if you spin that pressure relief valve, then if it spins easily, chances are it's not corroded. If you have to give it some pressure and then it spins easily, it's corroded in there. All right. If you can't spin it at all and it's so tight in there, it's corroded in there. If it's corroded, it may not open when we need it to open. All right. And that spring in itself is going to hold it at 150 psi. If the corrosion of that makes it up to maybe 160 psi, then the tank might become the weak link, and that could levy. And when these things go, again, I'd like you to watch that video on Mythbusters, and you'll see what it's just a big boom. That's all I could put on there. And it just destroys the little house that they built on it. This is a pressure relief valve we found in a house. We did not hook this up this way. If you look at the arrow pointing on there, it's actually pointing towards the tank. All right. So, I mean, somebody had to do some configuring to make this happen. They had to put in there a nipple in order to get a male threaded into the tank and then put the female to thread into the exhaust of the pressure relief valve. All right. And then they went ahead and put another female fitting on the bottom end. The water will not go backwards. All right. This is the same thing as a valve that comes in there. And it was funny. At this point in time, we would have 15 people doing our field trainings. You know, the rules have changed since then. We limit the size of the groups now. But out of the 15 people, including myself, all right, only one person caught this. And, you know, we just saw a pressure relief valve. Okay, that's cool. It's there. And nobody really ended up taking a close look at it. But one person goes, hey, how come this arrow's pointing the wrong way? And then all of a sudden you look at it and you're like, holy cow, that's dangerous. All right. So again, take your time, look at it, even if it's tedious. Do what you can to make sure that it's going to be working right. All right. Fallen baffles, we should see them hanging at the very top, right through the draft hood. If those little hangers break off and this falls to the bottom, it usually disrupts the flame and we get and it might damage the burners. Those burners underneath there are flimsy. They don't have any strength to it. So if something comes down and gives it a good whack, then it knocks it out of alignment pretty quick and easy. Isolation valves, drain valves, I think these are pretty much self-explanatory. I don't open them, I don't flush them, I don't do anything with them other than knowing that they're there. It's kind of weird. Part of me wants to open it and see if it'll flush because I don't want to ever get that call where my clients open it up to flush it and now it's continuously leaking and I didn't test it. But truthfully, I don't think any of my clients have ever tested that or really flush it. It's not in our society to do such. So I've never had a complaint call from an isolation valve leaking on that or a drain valve leaking. It just doesn't happen. Going back to nationwide testing. So the National Home Inspector exam is a nationwide test. So they are going to be asking you questions about different parts of the country. We are not in the Chicagoland area or Illinois. We are not in a seismic zone. So we're not required to put the seismic strapping onto our water heaters, all right? But if it is in a zone such as California where they have their earthquakes, I want you to know that there's 2 straps that need to be on there. I want you to know that there's 2 straps that need to be on there. And those two straps should be 1/3 high and 1/3 low. They should be fastened to the structure. And then the other thing, if you look at the bottom left, you're going to see that it's connected with a flexible appliance connector, just like we would do with a stove or a dryer. And the purpose of that is that if this thing does fall off the wall and does trip over, that it's not going to break the gas pipe. It might have a slow leak to it, but it's not going to break the pipe and you get a big leak coming out of there. All right. So Mark asked a question about do you let your clients know they should drain the water heater periodically? We have items like that pre-written in our report that, basically some gentle maintenance tips. And yes, that is in there. Do I verbally tell them that? No, I do not. So. All right, this one was just kind of a no-brainer. We got a gas water heater up on there, and there's no vent connector on the top. We also have a pressure relief valve on there that doesn't have a discharge tube as well. Those blue and red escutcheon plates that are on the top of the water heater where the pipes go in, I do want you to take note of those. Whenever we see backdrafting from a water heater, those are the first things that usually end up melting. So if you start seeing them deformed in any which way, it's a pretty strong indicator that that water heater has or is backdrafting. If they've been removed and cleaned up off the top of it, we really should start getting suspicious. Most people aren't going to remove those unless they're, trying to avoid something that we would find or something that would be called out. All right. Sometimes we're going to run into multiple water heaters, and there's two different ways to do it. I'm kind of in the minority on what I like to see when people do this sort of stuff, but the vast majority are going to put them in what we call series, all right? And I stand corrected. The vast majority of the plumbers are going to put them in what we call parallel, and that's what we're looking at right now. So basically the cold water comes in and it splits off, goes to both water heaters, and then the same thing with the hot water when it comes back. They both come together, and then that feeds the hot water to the house. Theoretically, everything, as long as they're equal, water's going to flow down the same line, plain and simple, all right? If they're different and different directions, water flow and friction loss all has to do the same with pressure differentials. So if I have the same pressure on both sides of them, water's really only going to flow down the path of least resistance. So you're going to end up using one water heater. Now, I've mentioned this, and I've had plumbers call me out when I had different water heaters, different lengths, and, they said I was full of poop, and I was totally wrong. But then we start running the hot water and just let it run, and the next thing you know is only one water heater is turning on and off, and the other one's just sitting there. So we keep running until we run out of hot water on everything, and the one with the longer run just never turned on at all. So I firmly believe this is true. And anytime I see them in parallel, I do check and make sure that the distance between A and B as shown on these diagrams is identical. And the same thing for the hot water side. And both water heaters have to be identical. I'm talking not just the same manufacturer, same year, same manufacturer, same size, same height. We can't do anything that's going to change the flow. All right. So this is one of those hills that I kind of die on, especially if somebody wants to fill up a big tub and they're having trouble doing it. I'm actually going to try and fill up that big tub and see if we can succeed in doing it. For me, the easier solution is to put them in series. Now here, you can see the cold water goes into one water heater, and then the hot water comes out of there and goes in through the dip tube into the second water heater, which goes ahead and feeds it to the house. So as I'm using the hot water from the left water heater, I'm actually replacing it with more hot water. So I'm going to get the longer lifespan out of it. And when I run out of the hot water on the right water heater, now the cold water is going to start coming in there. But even that's going to be lukewarm. And to me, it's just a way to use all the hot water. You know, it's just all the hot water is just an easier, more verified way that it's going to happen. Now the drawback to this. The only water heater that's really going to be doing most of the work is the one on the right. The one on the left is just going to be maintaining temperature unless you start exhausting all the hot water in the system, and that's the only time that's going to be doing it. Otherwise, they'll just mate. So the one on the left will last longer. The one on the right will fail soon or sooner. All right, but no sooner if you had only one water heater. All right, it would be the same. So, and then you don't have to replace both. You can just replace the one water heater and everything will still work fine. So just my opinion, my 2 cents and how I feel about it. I'm not going to tell anyone to repipe anything. I don't have that in me. But I do want to give them fair warning if they are going to run out of hot water. So, flame rollout shields. Look for any sort of corrosion on the top. When you start seeing that rust and corrosion, typically we're backdrafting. Now, or I shouldn't say backdrafting, we got flame rolling out of the bottom there. Or some sort of heat coming out of there, and that's what's causing the corrosion. Now, the newer water heaters are all flame-resistant water heaters. So it's a sealed burner. We're not going to be able to peek in there at all anymore. So things are just different, plain and simple. But nonetheless, I want you to know what it looks like and what it is. There's our burner on the inside. And again, we're not going to be able to see these on water heaters anymore. But that's just flimsy. It's a piece of thin metal. The line goes in there. We do have a pilot light in there. And then just heat coming out of the sides. And if it spills out, that's where we get that rust and corrosion on the top edge. And getting that little piece of metal back in there, I can't tell you what a pain in the butt that is. There's got to be like some secret agent decoder ring or something that you got to go in a certain way that I've never been able to figure out. All right. So the sealed ones, or the FLIRs, they're called, the flame resistant. They're all sealed. You can't get in there. I think I can. The next slide, yeah. So this is a close up with that blue lid removed. There's a button that we could do to light the pilot light, so we will get it in there. We do have a peephole to peek in there to see if it's lit, but nothing more. All right. If I go back a slide, those holes that are on the left and right, that's where my combustion air goes in. And as it goes in, it goes to the top of the tank. And then it comes, or I should say top of the vessel. And then it comes over an edge. And then it comes back into where the burner needs it for the combustion air. This is supposed to stop any gas fumes or anything else from being able to get to the fire and causing an explosion or a flame on there. By the way, that is the water heater that was in my old house. I did have to replace the original one. And I did try and bring it down the stairs all by myself. And I did put that dent into that water heater. Just saying. If a water heater's in a garage, and this is more of an exterior garage thing, anything that has a gas appliance, the flames, or anything in a garage has to be at least 18 inches off the ground. And anything that is an ignition source, to be clear, has to be 18 inches off the ground. Instant hot water heaters. I did it. Instant water heaters. They're becoming whole house ones. I put one in my house, and me personally, I think it's phenomenal. Never run out of hot water. We could take 2 showers at the same time. The drawback is they do require maintenance. And they do need to be flushed, and they have cleaning kits that get in there because the pipes are so thin on those that there's a lot of calcium buildup on it. So it is something that needs to be done. Private wells or private waste systems. We talked about wells already. So we'll get into the septic systems. Again, the septic systems are going to be done by a well and septic guy, and they're going to be given the certificate. That gets done from the seller of the home, and it usually doesn't fall under our realm of things that we do, for lack of a better word. They're usually buried. There's usually going to be a map so that if somebody has to dig out that opening at the top and find out where it is, the guys that actually do this sort of stuff, they actually swear by those divining rods, and they're able to find these tanks quick and easy with that. I still don't believe it, but I really don't think they were lying, so I do believe they believe it. But nonetheless, there's 3 layers inside of a tank, all right? So as we're looking at this tank, the wastewater comes in from the left and goes out to the field on the right-hand side. I want you to know the 3 names of the 3 layers. So the sludge is the solid layer, so the sludge is at the bottom. The liquid is called the effluent, E-F-F, effluent, I think it's L-U-E-A-N-T. And then the foam that's at the top of everything else, that's called a scum. So whenever we called somebody scum, we were referring to the foam that flows on top of these septic pits, which I don't think is a nice thing to say, all right? Most of this we want to always be water. That scum layer, or the foam layer, that should be less than 2 inches. The sludge layer on the bottom as well, I forgot the exact number on it, but that should be like less than a foot. I think one of our next slides goes ahead and shows that. On some of these pits, we're going to have 2 tanks in them, so they're going to kind of keep the sludge back a little bit longer and just let the effluent pass through. Some of them actually have 3 tanks as well. So here's the slide that I was looking for. 24 inches is what we want to keep it under, and we're not going to know that. When that happens, when it gets thicker than that, then it's not going to really be able to eat itself up with bacteria anymore. So somebody's going to have to go in there and scoop that all out. And I think the tool that they use to scoop it out is called a honey dipper. I think it's a fitting term for something like that. And get it all nice and clean. Things I do like to coach my clients on when they do have a septic field is using any sort of bleach products and putting that in there. It kills bacteria, and we really don't want to kill the bacteria that's inside this tank, because we need that bacteria to eat away at that sludge and keep changing that back to a liquid so we can get it out into the earth and let it drain into the earth safely. I've heard people putting, Rid-X is one product that they put in there. Another one is quick rise yeast, I've heard of people putting in there. Flushing those down the toilets once a month, just to be proactive and keeping that bacteria growing and keeping it alive, I think is a good thing. Now, I am no way an expert on this, so I'm just sharing information that I heard. I've always lived in an urban area. I've never had to deal with a septic field or septic pit. So these are just the numbers that I'm hearing from other people where it comes to it. But yeah, if you have a bleach that goes in there that's going to kill it, most people use on their washing machine, they'll take that gray water and they'll put that on top of the earth. They won't flow that through their septic pit that comes in there. And same thing with chemicals that you flush down your toilet. You want to be careful that you're not going to kill the bacteria in the toilet. So we come out of the house, we go into the septic pit. From the septic pit, it's going to have those different baffles in there, and that's where the cleaning is going to happen. Then we have the effluent, or the liquid, is going to start going out into our leach field. All right. Typically, those are 2 to 3 feet deep. Excuse me. Those are 2 to 3 feet deep. As we come out of that catch basin, that's that big rectangle at the top. It's going to go through a distribution box. Then those perforated tiles are going to be typically 10 feet apart. They're going to have perforated tubes in them. They're going to allow for the water to drain through. There's going to be a whole bunch of gravel in there as well, so we can let the water drain through easily that way as well. When everything's working properly, we're just going to see a little bit of greener grass wherever these things are, because it's going to be watered and fertilized better than anybody else is. So when it's not working well, you're going to start getting sewer smells in the backyard. Any sewer smells outside is an indicator that something's going wrong. Now, we don't necessarily have to diagnose it. It doesn't fall under our field of work. But I think we would be doing our client disservice if we didn't tell them that they need to get somebody out here who's aware of this. So, where we can keep stuff in tile beds too, we got to stay 50 feet away from lakes, rivers, things like that. 15 feet away from a house, keep it away from the lot lines, keep it away the septic pit from the house as well. Sump pumps. This is a typical pump. I'm a firm believer of battery backups as well. Most of them are going to be electric powered. There's going to be some sort of a float valve in there that is, once the water gets to a certain height, the pump automatically turns on, pumps the water out. Usually there's going to be a screen at the bottom of this pump. And so we want to be careful with the sump pump that there's no debris that's tossed into that. We want to make sure there's no paper or anything else that could go ahead and clog this screen up and prevent that water from flowing. Obviously, if it did, then that water is going to come into the house. Battery backups. Typically, it's going to be a secondary pump. Again, in our area, because we do have a lot of basements here, I'm a big firm believer of that. But it's not just for power outages. Sometimes you're going to get a pump failure. So at least now I got a secondary pump that's going to step up and pick it in there. Maybe I'll get so much rain that one pump isn't able to remove the water as fast as it's coming in. So now I'm going to have two pumps that are going to be able to remove that water. So it's more than just for power outages, battery backups. Again, I think they're just fantastic. All right. I've seen these a few different times, and they work with siphoning water. And again, you're not using batteries or charging as long as your as long as your water company is able to provide water to you, then your battery backup is going to work as well. Or I shouldn't say battery backup, your backup sump pump is going to be able to work. This one ends up, when it calls to operate, it allows water to flow and shoots it up there, creating a Venturi effect. That Venturi effect is going to siphon in the water around it, and that's going to get it out of the system. So it doesn't require a battery or charging or anything else with it. It just needs a water pressure to be connected to it. Ejector pumps, also known as sewage ejector pumps, these are designed to get rid of waste materials. And I do have some gross conversations with my clients whenever they move into a home with the ejector pumps. We as human beings, we have habits, and not all of them are good habits. So sometimes we're going to, flush fish, tampons, condoms, different items that aren't able to be chewed up, nylons. They're not able to be chewed up by these pumps. And they're just going to get that pump and bind it up. And those things are expensive. They're almost $1,000, if not more, for a good ejector pump. So make it clear that the only thing that goes in there is feces and toilet paper, not even wet wipes, all right? Or even if it says it's disposable and it's safe for sewer systems, those will get in there and gum the works. And then if it just turns into a glob of mud and it doesn't get disintegrated, then that pump is going to overheat or bind up, and then you're going to end up replacing it. And you don't want to go into wastewater tanks to replace a pump. So the longer we can make this thing last, the better off everything would be. All right. I do want you to know that ejector pits need to be vented, they need to be sealed, and they need to go into the raw sewage lines. All right. Where some pumps, they don't. All right. Some pumps don't need to be sealed. It's nice, unless it's a radon system. We don't necessarily have to seal them up, but they're going to go either outside on the surface. Now, the city of Chicago is unique in the state of Illinois. The city of Chicago, because they put their houses so close together that they're only 3 feet away from each other for those gangways, sometimes 5, they don't want all that water running on the surface. So they put their sump pumps into their raw sewage. They don't discharge them outside. It's not wrong if you discharge them outside, but they encourage you to put them into the raw sewage. All right. None of the suburbs allow you to do that. They all have to be Only ejector pumps can go into the raw sewage. Some pumps have to go outside. All right. So that's really all I have for plumbing. I think I have a few other slides here. Let me just scan these things. These were all drawings that I was working with and trying to make things go. But that's pretty much it that I have. And we'll put it on there. Sorry for all that moving. So if anybody has any questions, shoot it out. Otherwise, it looks like we went about 2 hours and 40 minutes. So I thank you. I appreciate your time. I hope this helps. You know, if you picked up one or two things, that makes me happy. If you picked up nothing, come on and work for me. All right, I would love to have you. So, but nonetheless, unless any questions pop up real soon, I'm going to go ahead and end this.